Hello, welcome back to the channel, guys. How are you doing? Hope you enjoyed yesterday's debate with Richard, who is just a Witsit clone and knows nothing about anything, so that was fun, explaining the same thing a million times. But we'll see how tonight goes. We have a new flat earther, Carl, from Facebook. You have not seen him before anywhere else, so I've seen people in the chat wondering who he is, but no, he's brand new. I hope you're all having a good day. So we are going to do an intro. You know how it goes. There's music. So if you're watching this as a VOD later on, just skip the next 90 seconds or so. You don't need to watch it. But if you're here watching live, you don't get a choice. So you have to watch the music. And if you're watching the music, you have to dance. If you don't, I send Daniel Pratt to your house. If you do dance, then you can have a cookie.
We're living on a disk, floating through space, with a tiny sun.
Hello, welcome back. You're here to watch a new Flat Earth debate. No more Mikey today, but he may be back on Wednesday. Michael asked us to debate Professor Phil for the second time. And I'm sure you'll just have a headache after that as well. So I'm kind of sorry. Do all the YouTube things, like the stream, share the stream, subscribe if you're not already. Grab a brick, wrap it in paper, write the URL and throw it through a car window. I'm sure someone would join. Anyway, we're going to get Sean on, Carl on video, and you can say hello. Carl, hello, welcome to the channel. How are you doing?
Hi, doing great. Thanks for having me. Yep, my name's Carl, from the East Coast of the United States, and I'm on a Flat Earth show. But fantastic. Hope we can have a good debate tonight, and I'd love to, hear your thoughts on everything.
Okay, so how long have you been a Flat Earther?
Yeah, definitely. So never was, historically. Honestly, I was very tied up in the Anunnaki myth, to believe it. Was very sold on that for quite a bit of time, probably just about halfway through college, kind of started to question some things. Definitely always been very critical about, topics like that, a couple other more out of the box ones, but really definitely started picking up in the last 8-9 years, so good amount of time. But yeah, I was very sold on the Anunnaki for quite a bit of time, the ancient aliens thing. I still think those ideas are pretty interesting, but my perspective has definitely changed. Definitely very open to both sides of the topic. I'd love someone like you to come on and just show me some compelling evidence. I haven't, from what I've seen, I just haven't seen what I'm looking for to sell me on it.
Right. Okay. So have you got evidence that the Earth is flat? 'Cause I've definitely got lots of evidence of the Earth being a globe and rotating, measurements, experiments, and everything. So if you got, we go through your evidence for the flat Earth, and I can go through my evidence for the globe, and then we can have a discussion about it.
Okay.
All right. So
Yeah,
I'll give
absolutely.
you 10 minutes. Do you need to share your screen or anything?
No. I mean, I could have put some stuff together. I don't really have anything kind of visually right now, but No, I don't need to share my screen.
Okay, all right.
But
Well,
yeah,
I'll give you 10
basically,
minutes starting now. Then over to you. Tell us why the Earth is flat. Give us the best evidence you got.
yeah, definitely. So basically, just to begin with, there's three things every child in America knows before entering kindergarten, and that's going to be dinosaurs, the globe Earth, chicken nuggets. So basically, why are we indoctrinating kids at that young of an age when they don't have critical perspective? Why is that so important? Why are you seeing a globe on every teacher's desk
Behind
as soon as
bars,
they enter this?
unquote.
Sorry, carry on. My bad.
Oh, good. Didn't know if you were talking.
No.
But there's definitely a level of indoctrination being shown to kids before they develop the fundamental ability to critically question things, to have that critical understanding. So they're being shown this fundamental, they're being told a fact before they have the ability to question it, before they have even the understanding of the mathematics that will be required for the celestial model. They're being shown heliocentrism at such a young age. That's kind of the groundwork for what we're looking at, why they're being shown that at such a young age. So for the next 10 minutes, we've established basically you live on at least by the model, and I can explain the model, but I think most people have a similar understanding in the flat Earth community. Basically, North Pole, flat plane, everything points north to direct North Pole. North is every direction, east, west, you make the circle around the Earth. South goes to Antarctica, which I'm not completely on board with the ice wall thesis. It's an interesting analogy for what we're looking at, but there is definitely a circular body of land on the perimeter. It does form a perfect perimeter. I do believe that there is more or less a firmament, whether you want to call it the Van Allen radiation belt or an actual dome, physical, debatable. I have not seen it. You stated that you have been to Antarctica, which is fantastic. I'd love to go one day. But that is where the perimeter of the tertiary plane that we call Earth would be. So the static model, nobody feels momentum on a daily basis. We're all very standardized in believing that. You don't feel acceleration in either direction. We're counting on basically four different dimensions of acceleration that we would be experiencing constantly, that we don't have any reflection on or any response to. So you have spinning, Earth orbiting the sun orbiting the Milky Way, and Milky Way orbiting whatever celestial body is above that in the globe model, the heliocentric. But basically, we can all establish that we don't feel motion. Everything that you could observe basically is non-motion. So the burden of proof, I do feel, is on proving that it is globe Earth when all of your senses would imply we're not moving. I don't subscribe to the history of it. I know there's been a lot of cultural significance in it, a lot of religious significance in it, but don't think it's necessary to get into that. But the burden of proof being on the outside observer to prove that we are on a spinning ball. Right now, the only verification that your senses would tell you is that you are stationary, you are planar. You can see the horizon. That's pretty much the extent of it without the augmentation of technology, without telescopes, satellites, that nature. But basically just identifying the burden of proof would be on the external. Looking at the history of kind of the revelation leading up to NASA, going back to World War II, the first operation directly following World War II was Operation High Jump. 47,000 men went to Antarctica in 1946, directly following the most significant military operation since World War II done by America was Operation High Jump. Admiral Byrd, we went down to Antarctica. The mission was cut short. Debatable as to why that was cut short. Some people allege there were unnecessary casualties. I wasn't there. Nobody else was there. We can't really have any verification of what they actually found in Antarctica, but it was clearly a significant military operation which held continued significance going into that. Following Operation High Jump, Operation Deep Freeze culminating in the International Geophysical Year. Operation High Jump continued long-term exploration, scientific research in Antarctica, led up to the International Geophysical Year in 1956, where all major developed nations, most of the participants of World War II, which couple things that may have happened in World War II, but I'm not going to speculate on that. Definitive fact, the International Geophysical Year was the initiation of all the major nations on the planet who decided, amongst political differences at the height of the Cold War, that preserving Antarctica as a scientific and exclusive research location took precedence over national security, over everything else, leading up to the Antarctic Treaty signed in 1959, where again, every major nation determined no territorial land claims could be made on Antarctica. Only use for research purposes is the only, factor or objective that you could go down to Antarctica for, and no more territorial claims. So at that point, you have every nation on the planet, including the USSR, the United States, at the height of the Cold War, during the height of the nuclear arms race, determining that the preservation of penguins was superseded national security and took precedence of that fact, which in the signing of the Antarctic Treaty, they, repeating myself, but they determined that scientific research of penguins superseded national security. Nobody can go in, nobody can do anything else, no territorial claims again. Following the Antarctic Treaty, we run into Operation Fishbowl. So the premise going with this is that they found something of significance. I would call it, to some degree, a firmament. I don't know, again, if it is a firm wall, but they definitely had definitive proof that we were living on a tertiary plane, enough to the fact that there's physical barriers that we can't expand upon. And we began testing that and mapping that with the Operation Fishbowl, which were high-altitude nuclear detonations. So by launching nuclear rockets into the sky, they were testing the strength and mapping the firmament dome. Ironic, the name Operation Fishbowl, but 1962 high-altitude nuclear tests describing the physical characteristics of the environment we were living in, which under the model is a dome firmament. So kind of brings it to the next point. We have thousands of satellites, allegedly, yet nobody has ever been able to take an unadulterated picture of the Earth. Every single picture, they have images they'll show us, composite, CGI, but they have never been able to take a single frame image of the Earth. NASA only uses the composite, no still frame images. They just use composites of flyovers and CGI. It's why you get the repeating cloud figures in the images they show from NASA. So again, very unverified. I'm not asking whether NASA has images. I'm asking how those images were actually produced. Some with astronomy. Yeah. So again, NASA, the evidence that will be shown, and I mean, there's obvious flaws with NASA, but every space agency on the planet, they're coordinating in this, and you could ask yourself what benefit is that serving, but we can look at the extreme flaws of NASA, namely the ISS, the Apollo missions, and the Voyager missions. The ISS in itself has only provided us CGI images, green screen images. The two types of videos that NASA will show us from the ISS are the short version, short form, which were the 90 seconds of when a plane is going up and down, where they simulate weightlessness, or the long form, which are clearly CGI and green screen. I could show you hours of those videos with obvious mistakes that don't make sense in the fact that they don't abide by the laws of gravity in the way that you would expect them to. They'll have toothpaste bottles moving uninterrupted and stopping in mid motion, which according to your thesis on gravity would not apply. Thesis on gravity itself, very unproven. We have gravity is a theory. You have they haven't determined what the vector is. Some claim to be gravitrons, which wouldn't make sense, would exceed the laws of light if you had every piece of matter in space contacting every other piece of matter in space as well, disregarding distance or distance not being a factor in that. Should write my notes better. Voyager went out in 88. We lost contact. They reestablished contact in 24 at 18 million miles away, which would take irrelevant. NASA, fifth largest purchaser of helium on the planet, 98% of all international communication is done by undersea cables. There's no outstanding evidence that satellites are relevant for any form of communication. You could ask yourself, if the satellites were turned off, would any of your communication be interrupted? The answer is no. All of ground-based positioning can be proven with, or conducted with tertiary radar connection, line of sight. Yeah, but I mean, to drum it up, there's no evidence that we are moving in a celestial plane. The mathematics doesn't make sense. Earth can be, gravity can all be fundamental down to density and electromagnetism, buoyancy, affects everything the same way mathematically. There is no evidence of gravity as the subject of the defined in science. I should have read this. And then again, for the model, local sun, 3,000 miles away, the moon, similar size, covers up the moon. That's why we have the evidence of eclipses. And yeah, I mean, just by observation, I don't have anything further. I do have the idea for a test. If you were to conduct an experiment, I definitely do have an idea that would prove it one way or the other. But yeah, I'm just not compelled by it. But yeah, that's, I guess, pretty much my thesis right there. A little chopped up, but that's pretty much all I got. I would focus mainly on the primary for the history part with Operation High Jump, Operation Fishbowl. I think those are very compelling arguments, at least to question the narrative. Many reasons to question the narrative, including why every developed country on the planet would agree to this if it wasn't to cover up something in that effect. Yeah.
Okay. I noticed no evidence, just what I would describe as rhetoric. So that's always interesting. And okay, to be clear, in a debate, both parties have burden of proof. You have a burden, I have a burden, but my burden's pretty easy, to be honest. If you want measurements, we can just go to the professionals like surveyors. Jesse Kozlowski is a surveyor, and he used his surveying equipment to measure over a mile lake and test the claim of if water curves, if the Earth is a globe. And turns out that after doing his measurements over quite a long period of time, that there was in fact a drop from the tangent of exactly what we expect, of 8 inches per mile squared. You can go and check out the measurements yourself. But when you go down and actually do the calculations based on the measurements that he took, you find that the drop from the horizontal plane is exactly 8 inches per mile squared, exactly what is expected if the globe is what we say it is. Of course, these measurements are backed up with measurements. Every single measurement that's ever done shows that the Earth is a globe, including other surveyors, like ones that did the transcontinental triangulation and the American arc of the parallel, and pretty much every survey that's ever been done across large distances show that the Earth is a globe, the exact amount that we expect it to be. So we know that the Earth's a globe, and of course we know that we can look at it from space. So this is a single frame photo taken with a camera, nothing digital. This was before digital. This was 1972. So that this is not a composite. This is not a CGI. This is not digital. This is not run through any kind of digital. This is just taken with a Hasselblad camera and developed in a darkroom like you would normally do with photos of the whole Earth from 1972. So when people claim that there is no pictures like this, I don't understand it, because we've been getting pictures like this since the 60s. We've even got pictures of Earth from space from the 40s when the Germans went up. So the claim that we don't have this is just false. Here is a picture from space, single frame, exactly as we expect. We know that the Earth is rotating. We can measure that the Earth is rotating with something as simple as a pendulum. If the Earth is a rotating globe, Coriolis forces are applied at different latitudes, different amounts. So if you swing a pendulum back and forth over time, the pendulum will drift off of a straight line path. and you can measure the angle that it's drifted over a certain amount of time, say 41 minutes. So just measure the angle, find the angle 7.89 degrees over 42 minutes, then do Foucault's sine law to calculate your latitude on Earth. This works because depending on where you are on Earth when you do this experiment, you get a different result, but the result correlates to your latitude, which is the prediction of the globe. So we know it's rotating. We can measure that the Earth is rotating. Flat Earthers measure that the Earth is rotating. Thank you, Bob. So we do know that it's a globe, and we do know that it rotates. The acceleration that a rotating globe puts out is actually what we expect also, because at the equator you weigh less than you do at the poles, because there's more centrifugal acceleration at the equator, because we're moving very, very slowly. We're rotating once per day, which isn't very fast. If you add up all the forces from all of our movements, all the acceleration due to that, it's actually very, very, very tiny. Space is obviously real, and so is the ISS, and that couldn't be the case if Earth were flat. The claim that there is no long-form videos of the ISS is also very false. This is a nearly hour-long, uncut trip through the ISS with a camera that films the camera at certain times, going through doorways constantly, which would be impossible if he was on a harness of some kind. And there's no evidence this is CGI. There's no physics here that apply to being on Earth the way that he's moving for the entire time. Goes through the entire ISS for nearly an hour, which would be impossible to fake. It would cost millions and millions and millions and millions with ultra amazing good CGI, which this was done before that, really. So no claim of there's no videos of this will fly, because here is a guy in space giving us a tour of his space station for nearly an hour. The things that you said, none of it was evidence of any kind. You just misunderstood a few things. Said something like gravity is just a theory, which is not. There's a theory of gravity, same as there's a theory of music. And then you, well, we'll get into the rest of it now. But yeah, so Earth is a globe. All the measurements, all the experiments show that Earth is a globe. That's how we do evidence. Right. Thoughts?
So in that ISS video, though, which I only saw a few seconds of it, first of all, with the ISS, my major issue, the wiring on the ISS. No self-respecting electrician would have the wires as sporadically laid out on a multi-million-dollar.
Well, the thing about the ISS is it's not one installation. It's a modular station. Right, the wires are set up in a way that makes things easy to change and swap in and out as you put new experiments in and take old experiments out, upgrade experiments. And the wiring's actually quite tidily managed, but they don't have walls to hide wiring behind like an electrician on Earth does. It's actually, when you look at it quite closely, it's very, very, very tidily managed, but it's hanging out of the equipment because they don't have walls to hide it in. It's as simple as that.
So every single image of the ISS, including the one you just showed, has sporadic wiring. I mean, obviously,
it's not sporadic. It's inexact. There's a lot of wiring, but it's not sporadic. It's exactly where it needs to be. And as an engineer myself, knowing the constraints aboard the ISS, the job that they do, you're changing and upgrading equipment, is pretty impressive.
I find that hard to.
Well, that would
accept.
That would be an argument from incredulity. That's you just not believing it, but that's irrelevant. Are you an engineer?
That the reason that the wiring on the ISS is a complete mess.
It's not a mess, though. It's exactly how it needs to be. It's not messy. There's a lot of it, but it's well managed. It's all cable tied. It's all put together exactly the way it needs to be, so that they can move equipment about when they need to. I mean, I don't know if I don't know what qualifications
to have transferable, but at this point, like you said, it's modular.
They're constantly changing the experiments they're doing out there. It's a mobile science lab. That's what it is. It's a mobile science lab, a few hundred miles above us, and it's a science lab that they don't have the luxury of, building new segments while they're up there. That they it's modular, so once they take one thing out, there's space to put something else in, and the wires need to be able to interact with the equipment. Sometimes the equipment needs to be moved about while they're doing experiments. But there's no sporadic wiring. There's wiring where it needs to be. And, it's designed by engineers that know what they're doing.
The ISS.
The construction. There's lots of video of the construction.
And again, that was, like you said, I haven't seen that video. You say it was long form. My argument on that would be that it's CGI. It would take me time to go over that video to identify key elements.
We've done analysis on it. It's not CGI.
A lot of what I was looking for in that video clip that you just showed were instances. The most common one that I see, you can see it. There's a very good one of the woman showing how you wash hair on the ISS, where 2 instances she taps a toothpaste bottle and the toothpaste bottle is hanging and it rotates like a pendulum and then stops with no contact to the wall or anything else. And with freeform gravity, if you're saying there's no contact,
you show us that video?
Would continue moving. Yeah, I mean, sure. I definitely clipped it before. Let's see.
A lot of times they just literally put things in a place and leave it there.
Yeah, it was the part about it that drying hair and space.
Yeah,
washing hair in space. Yeah,
PhD Professor Clive Wells in the chat points out, if it were faked, it would have been easier to add walls to cover the wiring, but they didn't. The way it looks is evidence that it's not faked, because if you were going to fake it, maybe you could make it look a bit tidier. You've muted yourself somehow. There's no audio from you. I can't hear you all of a sudden. Yep, still no audio.
Oh, sorry, muted myself.
There we
Apologize
go.
for that. Okay. So I do have the video pulled up. If you'd like me to share, I can.
Yeah, just request share and I can put it on for you. Yeah, you should be able to share.
Trying to find.
Bottom of the button says share.
Share. Okay. So this was the. Oh, Jesus Christ. Kill me, mate. This is the video. The exact moment is when she strikes this toothpaste bottle here on the right. I don't know the exact time frame. Might be right, yeah. Not really want to watch this woman dry her hair.
I mean,
should have
her
clipped
hair
it.
doing that? And how is her shirt floating up around her neck? And
movie magic.
yeah, I mean that's just a get out of jail free clause.
Okay. Even just that. God, where's the toothpaste? Right here. Gotta be. No. This Colgate bottle right here gets struck.
I mean, it is on a bit of wire attached to the wall. You do know that, right?
Bit of wire attached to what?
The wall. They have all their stuff on like wires, little like wires attached to the wall there. So I mean, maybe that would stop it when it moves.
This entire panel is
I
shaking.
didn't see the Colgate thing move at all.
Yeah, I know it's this video clip. I don't know where it is though. I don't know if I want to waste everyone's time with this, but she strikes this, it moves like a clock, like a pendulum, and then it rests without any outside force. Kind of similar to what that's doing. Oh, no.
I mean, without seeing
I
the video you're about, I can't comment on it. But I mean, I would have to ask you to do the maths to show exactly what should have happened with the forces applied. I kind of guarantee that you couldn't, to be honest. But you know, there's hour-long videos from the ISS. We can verify the ISS is real. One of my subs recently sent me a recording of him contacting the ISS using his radio as it went out above him, which anyone can do. I've got other people in the community that have measured the distance to the ISS from the ground themselves using their own equipment. You can look at Red's Rhetoric and you can look at Astronomy Live. They've literally measured the distance to the ISS themselves. So there's definitely something up there, the distance that we claim it is.
I firmly believe that there is something up there. I do not believe it is as high as they claim it to be.
But they no, my friends measured the distance to it. It's not just that they claim it. Any amateur can do it. You can measure the distance to it yourself. You just need one other person, a distance that, whatever they claim it is, like 200 and something miles. All you need is two people with some distance between them, both looking at it, and with going past something like when it transits the moon or something, and you can do parallax and some basic trigonometry and calculate the distance to it yourself. And when amateurs do that every single time, they find out that it's exactly how far above Earth that we say it should be. So there's definitely something up there at that distance that you can point a radio at and get a signal back from.
Okay. So I don't have a radio. I've not done the test. What was the distance that you're claiming that it was?
Whatever the distance is, I can't remember the exact number right now.
Okay, I'm not going to Google it.
I will.
250
miles.
250 miles. 250?
Yeah.
So that's not even above the. That's not even space.
That is space.
I agree. 250 miles is very plausible. I don't think it's lived on. The logistics of maintaining a population on the ISS is
it costs billions. That's why NASA spend so much money go back and forth to the ISS, and so does the Russian Space Agency. It's not cheap. The logistics is very, very hard. You are correct.
But locking 5, 6, 7 people in a hermetically sealed vacuum tube, they would be drowning in their own filth. None of these.
I was a submariner and once spent over 6 months under the water, in a hermetically sealed metal tube. Just because some people are insufferable, normally flat earthers, it doesn't mean that other people can't, live with each other. And they have a toilet that, takes their filth. That they have ways of keeping clean, they have ways of tidying, there is ventilation systems. There's no reason they'd be covered in each other's filth. These things have been designed in a particular way. You're just saying things that you think should happen, but you probably have no idea of the design implications or the engineering that went into designing the ISS to make sure that the people living there wouldn't end up covered in filth. So, I mean, none of this is evidence against the globe.
Or for
flat
Earth.
It's
it's not a smoking gun. I mean, these videos do not seem anything to prove that they are not CGI or edited, though.
Well, you'd need to give evidence of that. I've analyzed it, and I do CGI. I've had professional, video editors and stuff analyze it, and no one ever determines it's anything other than.
Why are there so many videos of bubbles, and why are there so many?
There's no videos of bubbles. There's videos of there's no videos of green screen or bubbles. There's just things that people claim are bubbles and green screen that are not. And if you show me a video in particular, I can explain exactly what it is. Like usually when you say there's bubbles, there's paints of flecks or something, flecks of paint or something when you're outside. paints of fleck. There's flecks of paint when they're outside the ISS, not bubbles. Bubbles would be a whole bunch going in the same direction, not dispersing in random directions like you see the bits of dirt and stuff doing in these videos. Again, none of it is evidence for the flat Earth. Even if the space was faked, NASA faked everything, it would not be evidence that the Earth is not a globe or evidence that the Earth is flat. It would just be evidence of a government lying. Big whoop. That's not new.
And I completely respect that, but
just quickly, Project Fishbowl. They weren't looking for anything. They were just seeing what happens with when you nuke up there and test the electromagnetic waves and stuff. We know they weren't looking for firmament because they did it at so many different heights, like at 60 miles, at 100 miles, at 230 miles. They did many different heights of explosions. That wouldn't be, they would kind of have an idea of where the firmament was. They wouldn't do it so many different times. Why does every measurement ever show that the Earth is a globe?
As far as which measurements are you referring to?
Every measurement ever done by a surveyor. Every radar measurement.
I saw your chart, and you're correct about the 8 inches per mile squared. I haven't seen any evidence of any surveyor showing that.
I showed you a surveyor showing it. That was Jesse Kwasowski, registered surveyor.
I mean, there was one singular image of a guy measuring a lake.
No, it's a whole website.
There's plenty of things that could account for a differential on one lake from shore to shore.
No, he's a surveyor. He would understand the differentials, and he used his professional surveying measurements and professional surveying experience to do the job that he does. That's it. He knows what he's doing because he's a surveyor, and he measured that over that distance there is a drop, and he didn't just do it once. He did it multiple times. And it's not just a singular image, it's an entire website documenting the process and the results. But it matches all the other measurements that have ever been done, like surveying expeditions like the Transcontinental Triangulation of the American Arc of the Parallel, measuring the curve of the Earth over the entire continental United States of America. Turns out it was 8 inches per mile squared for the drop from tangent at every single point on Earth. And then you can match that with the surveying expeditions of the United Kingdom, of India, of Asia. And they all say exactly the same. mctoon.net/r to have a look at them all.
Again,
there's no measurements of the Earth being flat.
At these. I'm not looking at the surveying numbers. I don't account for one differential across one lake bed being evidence that all of the surveying measures.
What do you mean one differential? What do you mean?
I don't think they account for surveying when they're conducting multi-mile railways.
Who doesn't account for surveying? Sorry, you said they don't account for surveying. Who doesn't account for surveying?
They don't account for the drop.
Surveyors do. That's their job.
When constructing.
Well, that would be plane surveyors rather than geodetic surveyors, because when you do construction, it's just over small distances. And because the Earth is so large, over small distances, the curve of the Earth is negligible, that when you're doing it like a kilometer or under, you can treat the Earth as locally flat because the Earth is so large. And over the mile, the deviation is so tiny it won't affect the construction. When you're doing large distance construction, like the Channel Tunnel, like the London Underground Piccadilly line, like the Venice Narrows Bridge in New York, you take into account the curvature of the Earth because they're actually extremely important. Do you know what LIGO is?
LIGO?
Yeah. It's the 2 kilometer long interferometer. There's a bunch of them around the world that they use to measure gravitational waves from space. And they are the curve of the Earth is taken into account for those because they're so big. Right? So they have to be completely 100% flat because they're a massive vacuum tube that you fire lasers back and forward and measure the disturbances in the space-time as the laser's going through them, right? And they have to be completely flat. And that means that when you actually build them on Earth, they deviate away from Earth because Earth curves away underneath it. So by the end, there's something like over a meter and a half of dip that they have to precision pour concrete to account for. And there's multiple of these over the world. So they do take the curve into the Earth when you do large distance engineering projects. Why would they do that?
So are you talking about? I'm sorry, I'm not familiar with this LIGO term. Are you referring to like operations like CERN?
No, CERN is a particle accelerator. LIGO is an interferometer.
So is CERN a curved ring?
Yes, but LIGO isn't. LIGO is not a particle accelerator. Uh,
Right,
a,
but
a particle
how
accelerator
would
just speeds up particles to slam them into each other.
I
An
understand the particle
interferometer is a
accelerator?
something that uses light moving along a path to measure things.
Right. So I mean, similar to the CERN operation,
No,
that it's
because
moving
you're
particle.
not
Light is
time.
also a particle.
Yeah, but they're not the same thing. What one is designed to test interactions
I
between
understand they're not the
particles.
same thing, but it's a similar principle in accelerating something on an elongated path.
No, you don't accelerate something. Light just travels the speed it does.
Okay. So accelerating towards light speed or moving at light speed would be the same in
No,
concept or similar in
no,
concept.
they're not the same. In the only way that they're the same is that they're really big. They're literally completely 100% different technologies on every aspect. Design, principle, conclusion, need. They're not the same in the slightest.
So what? I mean, if you could just so LIGO, I like. Do you have a visual of this?
Yeah, one sec. Can't believe you've never
Interesting
heard of
though, the
LIGO
vacuum
before.
tube of the laser. But yeah,
All right, here we go. So here's one LIGO Hanford Observatory. You see they've got this arm and this arm here, completely flat, humongous vacuum chambers. What they do is they fire a laser up, it bounces and then goes back down, and they test the disturbances in the laser as it's powered, as it's travelled, to see what's happening with space time. It's a it's a detector of gravitational effects from across the universe.
I've not seen that before. That is interesting, for sure, because that is similar to, kind of a way that I thought to potentially prove that. So what does it do exactly, though?
It
It
measures
just shoots light
gravitational
back and
waves
forth for what purpose?
to because the time that the laser travels can be
Right.
changed if the distance is changed slightly, and as big gravitational events happen in space, like if across the galaxy two black holes collided, it creates a ripple in space time, and that ripple perpetrates out at the speed of light, and as that ripple reaches us, and LIGO is shooting that laser backwards and forwards, it changes the distance that light has to travel by a tiny amount because of the warps in space time, and it's a way of measuring gravitational waves from space.
Okay, that I do find compelling. I will be honest, that does seem compelling. I don't. I would need to look at more of the fundamentals of that to make a determinate fact. But no, I've never heard of that before. So essentially, which was one of my premises, if I was going to prove it, you would have a vertical perpendicular vacuum tube. Essentially, what you are describing, if that's the way I'm understanding it, a vertical vacuum tube that shines a laser down at a centered point, and if it was calibrated correctly, the laser at the peak going down, if you had a target, if it hit at a deviation against a 90-degree angle, that would imply the movement of the Earth from the emission point to the reception point, and that deviation should match up with the rotational speed of the Earth. So that actually sounds very similar. And how long is this tube that you're describing?
2 kilometers.
2 kilometers. Interesting. It's kind of exactly what I envisioned being the test subject. No, I'd have to read more about that. I've not heard of that. And it's measuring gravitational distortion from space.
Yeah, measures gravitational waves. It can
Oh.
measure such tiny disturbances in the fabric of space time.
Well, yeah, exactly. You'd be obviously looking for something small, and you'd only be able to do it with, you know, extremely refined receptor, measurements. So that is interesting for sure. Definitely have to look more into that to make a determination one way or the other.
And
Uh,
so that's an
I
interferometer.
still
Did you know that a flat earther used an interferometer to measure the Earth's rotation?
am not familiar with that term.
So an interferometer means just using light to make a measurement, basically.
Right.
And have you heard that a flat earther used a ring laser gyroscope to measure the Earth's rotation?
Not familiar.
You never heard of Bob Nadell?
No.
Oh, I do like to introduce
I'm
flat
not
earthers
really
to this.
ingrained in the community like that.
So, got a little video for you to watch here. So just give me a sec. Oh, where did it go? There. Oh, it was young me. Oh, look at that.
If the Earth is spinning at one rotation every 24 hours, that means that every hour it has to turn 15 degrees. And if the gyroscope is mounted anywhere on Earth, it's going to drift. In today's 21st century navigation systems, they're using what's called a ring laser gyroscope. It is extremely precise. If we could simply get one of these ring laser gyroscopes, we would be able to prove once and for all that there is no rotation to the Earth. One of the people in the community actually purchased one for $20,000. But what we found is when we turned on that gyroscope, we found that we were picking up a drift, a 15 degree per hour drift.
And if we go over here, we can see him actually playing with the device himself.
Or an artificial horizon is what it's called. The aircraft
This
is mounted.
From the moon. So
Yeah,
that's
that's
a delay.
So this thing actually is mounted to the frame of the aircraft. Okay, so when you mount it on the aircraft, and say my front of my hand is the
Front of the plane.
front of the plane. All right, and you can see this thing right here, which what it is an attitude or an artificial horizon is what it's called.
Yeah, so, and as it's just sitting on his desk there, it's measuring 15 degrees per hour. Then later on in this video, we have a pilot, Wolfie. Where is it?
Well, what exactly is this measuring, though?
It's right, so, basically, imagine a device that's a ring, or, you know, a square or a triangle with mirrors that bounce light around. So you shine a laser in, and there's a mirror that's covered half in silver, and it splits that beam into two, right? And the beam travels around the path in opposite directions, okay? And because the speed of light is constant, as that beam splits, it should take the same time to go around both ways and then recombine at the other side. And that means the waves of energy will be exactly the same. But if the device is rotating or moving, that means that because it's moving underneath the light, it changes the distance that the light has to travel around the path, which means that they arrive slightly out of sync when they come back, and you get an interference pattern. And you can use that interference pattern to measure how much something has accelerated or rotated. And every single plane in the world has one to measure, you know, their movement, their yaw, pitch, and roll. And they're so sensitive that, you know, when the pilot turns them on, they're so sensitive they can use the rotation of the Earth to determine their position on the Earth. And that couldn't happen if the Earth wasn't rotating.
But I mean, that seems like it's only proving linear.
No, because it shows it in 3 axes. So it shows it in with your pitch and, well, hold on, what's your pitch and roll, right? It shows it in the 3 axes, right? So it's not just linear. It shows that it's multi-directional acceleration, multi-directional movement.
Again, I would need to see the data. I mean, that also, I would admit, is compelling. Would definitely need to see the data on that. I understand there's a video showing somebody stating, I use this laser, it proved it. I can.
Well, it matches every interferometer experiment ever done. It would be a valid
test if it matched the mathematics that were predicted.
And it does. It does match. It exactly matches the prediction of Earth rotating 15 degrees per hour. It picks it up. Boom. Done. Yeah. Right. See. So I see how I can present measurements of Earth's curve. Multiple of them. I can present measurements of Earth's rotation. But you couldn't. No matter how hard you looked, you could never find a measurement of the Earth being flat or stationary, of someone using
Why
equipment
can I
and
see
measuring it.
Chicago across Lake Michigan?
Well, you can't. You can sometimes see the tops of the buildings. If that was just a
have
true
you seen
image,
the famous photo?
yeah, where you just see the tops of the buildings, not the whole buildings, because there's a thing called
I
refraction.
see the whole building.
No, you literally can't. Because we always joke about it. Oh no, the Great Flood of Chicago. You literally, if you compare it to the actual up close seafront, it's completely different. Half of the buildings are all missing. Some buildings are just gone completely underwater. But we have an atmosphere.
You can see the Ardennes Mountains of France from Morocco.
No, you can't. That's clouds in that photo you're thinking of. But in our atmosphere, Carl, there's a thing called refraction, because light has to travel through a medium of varying density, and that because it's denser near the ground and gets less dense as you go up, naturally makes the light bend down, which allows it to go over the curve of the Earth. And in certain refractive conditions, especially early in the morning or late at night, when the temperature difference between the water and the air is quite a lot, you get refractive conditions which can make that light travel further around the Earth because of the light bending in a different way, which means that things in the distance, when you're looking at it, appear to rise up towards the horizon. I can demonstrate this happening in a different way if you want. It's quite an interesting video.
So you are so, despite the fact that I've seen those images, I know you understand which one I'm referring to. You're saying you're only seeing the upper portion, which in and of itself should not be visible. So despite that fact,
I mean,
saying
refraction allows it to be visible. It's visible because
so
of
you're
refraction.
saying the light is curving over.
Yeah, and I can show that. I can show that effect happening.
I mean, I understand refraction. I understand what you're saying. I just wanted to clarify that you are stating that this is in fact an image being bent and projected around the curve of the Earth.
Yes, exactly. Again, and that's a prediction of us.
It should be visibly blocked on a linear line. It should be visibly blocked.
Yeah, but we have an atmosphere that
could be obscured by the curve of the Earth.
Yeah. Right, so there's a video I want to quickly show you here. Bear with me. So this is an analogy of it. Okay, so what we've got here is a canister with some plasticine on. We've got a yellow band in the middle, a red band, and then like a bluey green band at the top, right? And what he does is he moves back. This is a curved surface, that thing in front of it, the canister in front of it. And he sets up the camera looking at the curved surface, so we get a horizon, and we can see the top bit of the canister with the plasticine on, like the blue-green bit. Below that's red, right? So right now, would you agree that the red and the yellow are hidden by the curve of this canister?
They're obscured by the canister, yes.
Yeah, it's because it's curved, right? It's a curved surface that gives it a horizon line.
It has nothing to do with the curvature. It's just obscured.
Yeah, but I'm just saying that it is curved, and you know it's curved because you looked at it. So we know that this surface is curved, and there's a horizon. So this is something being obscured by a curved surface, right? We both agree with that. Yeah.
I don't think the curvature is relevant, but it is.
Well, it is. I mean, but it is curved. You do agree that?
From the video, I'm looking at a still frame from what you showed earlier. It is a cylindrical object.
Excellent, right? So for light to then, for us to see the portion below this, the red bit, the light would have to bend around the curved surface, right? That's what would have to happen.
The light would have to bend. I still don't.
So,
I don't think the curvature has anything to do. I understand what you're probably about to show me, but I don't think the curvature has.
So there we go. Now we can see the red. So the light, and the reason we can see it is because this surface is curved, and when he poured that liquid on, the liquid propane, it changed the refractive index of the area over the cylindrical object, which made the light go further around it, bend further over the curved object to see what is beyond the horizon. And
okay,
you do it again. All right, so curved surface now has a curved density of air over it, curving the path of light even more, allowing you to see further. That's why the red bit pops over. And that's exactly what we're seeing on Earth. We're seeing a refractive index being changed because of the difference in temperature between water, as an analogy, and the air. Means that there's an area here that is like has a big variance of change in density, which bends the light. And then sometimes you can see further. If the Earth were flat, you would be able to see Chicago all of the time. Not just some of the time, all of the time.
I don't. I mean, you can simulate that on a plane too.
No, you can't.
Depending on the air variance.
A plane doesn't hide things bottom
the
first.
Refractive index. You could have differences in temperature and differences in air density that would simulate that shape.
Well, it wouldn't, because a flat surface can't hide something bottom first.
Can't hide something what?
Bottom first. So if someone was to go over that curve, if you were to move it over that curve, it would disappear bottom first. And a flat plane can't have things that have disappeared from the bottom and then bring them back up with refraction. They would just always be there. So you can't simulate that on a flat plane. It doesn't work.
Well, what about the images of a boat that's seemingly floating due to, I'm assuming, an inverse of that?
Yeah, because refraction changes wildly sometimes. And again, that's all a prediction. That's called a temperature inversion, where there's a point where the water might be super cool or super warm. So the air above it is very different from the air next to it. So the path of light does some really crazy things. When I was in the Royal Navy, and we were sailing around the really cold areas in Antarctica, there was points where it looked like the water was rising up in front of us, like we were inside a bowl. But that was just a crazy refraction. It changed in the next few minutes when we moved on.
Okay, I completely understand that. I'm not arguing whether or not light refraction exists, but that same scenario could exist on a plane.
No, it couldn't. There's no evidence that it could. There's no maths that says it could. I'm just going to quickly catch up with some messages from the chat. Stop the Stupidity gifted 5 memberships. Thank you very much. That does not mean I get to add time, because this is not the stupid membership drive I did last weekend and for 80 hours. Nearly broke my brain. It's a Rubiks for $2 says, indoctrinate from a young age like religions do. Yeah, I know. Showing you things in school that are reality is just a way to teach you about reality. And there's nothing wrong with showing us the truth in schools. So having globes there is absolutely fine because we live on one, and that's kind of important. Rachbot for $2 Australian says, who brought M&M from Temu? No, if you ordered it from Temu, who would have been about 8 weeks late. Julian the Inventor for $5 finally caught a live stream live, and I'm pretty sure I just heard the guy subtly deny the Challenger disaster. This is going to be a great debate. Yeah, we do not touch that with a barge pole. The Turtle moves for £2. Is there no conspiracy he doesn't believe in? Do you believe all the other conspiracies like chemtrails, against vaccines, climate change? Is that all fake? Dinosaurs never existed. Yeah, I'm just wondering to you. Do you believe all the other things?
I mean, I definitely wasn't the subject we were talking about, but yeah, I don't know. I don't know if I want to get into that right now.
Is jet fuel real?
What temperature is a burn at?
Well, that's a completely different question. Is jet fuel real? Do they actually put jet fuel into planes?
Well, there is a compelling patent by GE regarding the jump jet that 747s could be operated using electricity, and at the high altitude, they don't need as much.
As an engineer, my spirit just died a little bit because, no. Tim Davidson, $5. I measured the distance to the ISS using my weenie. 1.5 willies away. Get out. Golf Ball Turbo 199 says, Mr. Flat Earther, what is the circumference of Flat Earth? Because we know the circumference of Globe Earth.
It's a circle. So you do Antarctica to the North Pole, and then by R squared.
Which is what?
I don't know. Google's not going to have it. I'd be happy to do the math for you. I don't.
Where would you get the distance from the North Pole to Antarctica from?
You do distance to the equator times 2 times pi r squared.
Yeah, and where do you get those distances from? How do you know the distance to the equator?
I see your point. It's an interesting conjecture.
You get it using the Haversine formula or Vicenti formula, which is based on the Earth being a globe. Funnily enough.
Okay. Sure.
So you're talking about the azimuthal equidistant projection map, which is just a projection of the Earth centered on the North Pole. Julian the Inventor, $5 says the same size as the flat Earther's ego, incalculable. Smekai 199 super sticker, thank you very much. And then $13 says he knows aliens are real. Do you think aliens are real?
So I don't believe they flew here in tin cans. I truly don't believe in aliens. I think that's more of a complex issue. I think there's some kind of phenomena. I would not label them as, little green men flying in a tin can, though. Interdimensional. I mean, worlds out there. I've seen crazier things, but no, personally, I don't.
Okay. Right. So let me ask you a question, Carl. If the Earth did rotate, would the military, when firing artillery, have to take it into account?
Well, you would presume, yeah, or the railgun. You would presume.
Well, there's
they
no
have
military
to
that
account
use
for that.
an active railgun. They've only ever been tested. Plus, the
Well, we have a
railguns.
railgun.
No, they
We have a
don't.
railgun.
No, there's none actually in active service.
I'm aware, but we have one.
Well, there's ones that have been tested. There's none currently being tested. Right. Anyway, so you agree that though, if the Earth were rotating and a globe, when you fired a massive artillery shell, you would have to take it into account, right?
But yeah, if you were going a large distance, yes, you would. But
Right,
you'd have
so
to take more than the rotation account for. You'd have to take.
So this
Multiple
is a
rotations.
United States Navy range table for a 16-inch gun aboard a warship from 1941, right? And they fire up to 42,345 yards at a velocity of 2,500 feet per second. And in this and every other range table that you could ever find from any military, they have very important sections, which is the things you have to take into account. And one of the things that it tells you in the range tables is that you absolutely 100% have to, let me get to the part where it shows you, change from motion of target, where is it? Let me get right down. Sorry, I'm just trying to find the right bit for you.
You looking for the Coriolis?
Where it says that you have to correct for the rotation of the Earth, right? So range your current elevation.
And what year is this document
This
from?
is from 1941. Oh. Right here. So you have to. This is saying you have to adjust for the curvature of the Earth in feet. So here's all the calculations to account for that. And in the same paper, it shows you the amount you have to adjust for the rotation of the Earth. Let me get the other one up as well. So this is the second part of the table. And you've got instructions on here. All these instructions are for things you have to take into account, including rotation of the Earth. So why do military tables tell you to take into account rotation and curvature of the Earth? Affecting yards of range due to rotation of the Earth, which is what the Coriolis is as you're moving, the target across the Earth's surface. There's different Coriolis depending on what position you are above Earth, so it causes deflection. So when you're firing your gun, you have to take into effect in yards of range. So the further you fire, the more you have to adjust. And there's all the details here from 1941, and every other table you will ever find will also show you the same. So if the Earth were flat and stationary, why would the world's greatest military, the United States of America, take the rotation of the Earth into account?
I haven't seen that table, but
Now you have.
okay.
And I could
understand
send you
that.
1,000
Well, I've seen
more
the
as well.
document that you pulled up. You would theoretically think that no, you would not have to if we were on a stationary plane. So
I can also show you sniper manuals that show when you're firing over a kilometer, you most certainly have to take into account the curvature and rotation of the Earth. In fact, if you don't, you just straight up miss. So it's very important for snipers. That's why it's in their algorithm that they use. So Coriolis is absolutely real. Why is there Coriolis if the Earth is stationary, Carl?
I mean, there could be other factors.
Like what?
Like what else would cause a differential in an object being propelled a long distance? I mean, there's multiple factors that could account for that.
Why would that deviation correlate to your latitude on the Earth?
As far as you being at the equator versus a different...
Yeah, it will deviate more the further north or south you are from the equator. If you're at the equator, there's zero deviation because Coriolis at the equator is zero.
How do you figure? It's spinning faster at the equator?
Well, yeah, but because the direction of spin is perpendicular to the tilt, the tilt of the Earth, the axis of rotation, Coriolis net forces are zero. When you're at the point that is in alignment with the axis of rotation, that's when Coriolis forces are maximum. So that's why, for instance, no hurricane has ever crossed the equator, because there's zero Coriolis forces at the equator, which is exactly what we predict. Because the Coriolis forces also are dependent on the direction relative to the axis of rotation of a spherical object.
Perpendicular to the direction of rotation.
To the axis of rotation.
So if I'm aiming north, it's going to be a different vector than if I'm aiming west?
No, it would depend on where on the Earth you were. So if you were further towards if you were further up in latitude or north or south in latitude, so if you went to 45 degrees latitude north or 45 degrees latitude south, you would get a certain amount of deflection. But it depends whichever way you faced, and then if you went to the North Pole, or the South Pole, you would get the maximum amount of deflection. It depends where you are relative to your orientation. Relative to the axis of rotation.
I get what you're saying, but there should be no Coriolis if I'm aiming either due east or due west.
No, there's still Coriolis when you go east-west. It's the reasoning why is slightly more complicated. It's also to do with gravity pulling you up or down, and the fact that east to west would be going away or towards from the Earth as well.
East to west would be parallel to the spin.
Yeah, but the rotation makes you deviate in an arc. So that's what happens. So if you're firing west, all the forces combine to still make you deviate in a certain direction. If you're in the North Pole, you deviate clockwise. If you're in the South Pole, you deviate counterclockwise, right? So here's an image showing historical measurements of hurricanes, for instance, right? And as you can see...
I've seen the hurricane map.
Yeah, no hurricane has ever crossed the equator because that's where Coriolis forces are net zero. So hurricanes are caused by the rotation of the Earth and Coriolis, but Coriolis at the equator is zero, so there's no deflection of the wind as it moves across the surface of the Earth. And you can see in the north it goes clockwise, in the south it goes counterclockwise. So there's no
Coriolis at the equator?
No, absolutely none.
Shooting east. Okay, what about the orbit of the Earth around the Sun?
The orbit of the Earth around the Sun is gravitational.
But it's still an extremely high velocity.
No, it takes 1 year to go around, so the forces are very small.
Hey, 1 year exponentially larger in distance is still an extremely high velocity.
Relative to what? Speed is relative.
Relative to you shooting a bullet.
Bullets do go slower. Bullets on Earth are also moving that speed. They're moving with the Earth.
I mean, your argument is saying that the rotation is significant enough to impact that the orbit is umpteen times larger than that.
Yeah, with less forces, because if you want to talk about centrifugal accelerations, the longer it takes to do the rotation, the less the centrifugal acceleration, right? So any change, we're basically moving in a constant direction, which you don't feel. You don't feel a constant speed in a constant direction, right? The change, because of the path of our orbit, is so small and takes so long to happen that the acceleration due to it is practically zero, so we don't feel it. Because acceleration is the change in speed over time, or the change in direction, right? So
which centrifugal force incorporates.
Yeah, but because the change happens so slowly, that is taken into account when you do the calculations for centrifugal accelerations. That change happens so slowly, we are changing our path so slowly that any centrifugal acceleration will be practically zero. But this is irrelevant because it's a gravitational orbit, which is very different to something you experience on Earth. The centrifugal forces and that would work in a very different way. So again, Coriolis is real. We know it's real. It's measured. It's taken into account. If the Earth were flat and stationary, no military would take it into account, but they do.
I'm not seeing that they're accounting for directions incorporated in that, though.
I showed you the table, and the table shows, dependent on your latitude, you will have to deflect adjust the way you're shooting.
But if I'm angling 13 degrees north as opposed to 60 degrees,
yeah, that's all taken into account as well.
It wouldn't even. I'm sorry.
That's all taken into account as well. The direction you're firing.
You showed me a linear number set.
Yeah, that's because it says if you're firing this direction over this distance, you have to because that means the projectile will be traveling A to B, and then based on the arc that you give it, which also affect the distance and how far it's traveled. That means you have to adjust this amount. Basically, how far it fires, the total distance that projectile fires, it will deflect X amount. And if you don't take that into account,
and you add your longitudal data into that map?
Because if you don't, it's because, like I said, your Coriolis is different depending on your latitude.
Okay, so I have a different chart for when I'm fighting in Saudi Arabia than I do when I'm fighting in Russia.
Well, it's the same chart, but it has the adjustments on the chart depending on latitude.
You plug in your longitude or latitudinal data in there.
Yes.
I'm still not...
And they take it into account, is the point here, Carl. If the Earth is flat and stationary, why would they take it into account?
I mean, the military does a lot of things you wouldn't understand.
I was in the military, and I've used guns and taken it into account personally. It works.
Your longitudinal chart works?
Yeah. I've navigated all over the world in the Royal Navy, and it's all based on a globe.
I mean, I have to take your word for it. I was never in the Royal Navy. I don't see that linear chart being compelling enough evidence. Especially when
every military in the world has charts that say you have to take the rotation of the Earth into account when firing artillery over long distances. If you don't, you miss.
Coriolis effect.
Because of Coriolis. Because Coriolis is real. F-Grudge €2 says, Carl for president. I don't know, Carl, you running for president in 2028?
See how this video does.
Well, Julian the Inventor, $5. Coriolis isn't real. It's just the northern and southern hurricanes not wanting to touch each other because of weather cooties. Jim Daniels for $10. Jim, you punished me last weekend. Thank you. The new Flat Earth dual pool map has Antarctica as a continent and there is no longer an ice wall. What the heck is keeping the oceans from going over the edge? I haven't seen that one. Mr. Toffee's member for 53 months says the UK Navy had to change when it went to the Falklands. Yeah, so when the Royal Navy was fighting in the Falklands, right, their shots were missing by quite a lot. like double the amount that you would expect for the deflection. And that's because they forgot to change their charts for north versus south, because north deflects one way, south versus deflects the other way. So they were getting exactly twice the deflection away. And then they changed it to calculate properly.
Forgive me on my lack of knowledge of history. Falklands was in the 70s, 80s?
It was a long time ago.
Yeah, but, I mean, you had that chart from 1941, so you'd figure if that was in common usage, that would have been the first thing that they accounted for when fighting in a different hemisphere.
Yeah, they just forgot. That's the point. They used the wrong chart and missed by double the amount. But then when they started using the correct charts, they then started hitting their targets. AmJ204855 says, don't forget about gravity maps. Tony is asking to join. Right, I do have a PhD in the chat from Australia called Tony that has worked with Earth's shape and gravity in his job and would like to show you a presentation based on earthquakes if you're up for it.
Sure. Yeah. Yeah, sure.
All right, Tony, I'll chuck you an invite link on Discord, mate. Smake Kai says for $5, I love you, Carl, but you're not gaining any ground because it's impossible on a flat Earth. Also, apologize to the nice man talking to you.
When I find something to apologize, I gave you credence on the. I'm definitely going to look into the laser experiment. That by far is the most. Sorry, where did it go?
Right, so Tony.
The laser experiment is by far. Jeez, all right.
Lasers are light it refracts. So flat earthers never take into account the fact that light refracts.
I mean, I acknowledge refraction.
So you'd understand that laser experiments are pretty stupid if you don't register the refractive conditions and take that into account in your observations.
I'm not conducting a laser experiment. I'm not sure what you're referring to.
Well, you just brought up laser experiments.
Well, I was referring to your LIGO facility that you showed earlier.
Oh, right, okay.
I'm sorry, I'm getting a wicked echo.
Oh, I don't have one. Well, here's Earth from space over 24 hours from Discover satellite, of course. Full frame photos, not CGI, not composites.
So why does this image... I'm sorry, I'm getting a really bad echo. I don't know if...
No, it's not coming from my side. All right, Tony is here.
I think it is.
All right, you sorted, Carl?
No, it's... I'm still hearing myself.
Have you turned on the stream or something? It's not echoing on this side.
No, this is the only tab I got open. All right, it stopped, so right. I'm not sure what happened.
Tony, hello. How are you, my friend?
I'm well, thank you. I just need to correct you on most recent thing. That Falklands thing, that refers to the Battle of the Falklands from World War One, not the Falklands War.
Yeah, you are correct, of course. Thank you.
It's and the Falklands War was in the 1980s. But the thing where they're, and I'm not sure if it's true, but we hear that their firing solutions were out of date during the Battle of the Falklands, which was, as I say, in 1915. It was much earlier than the chart that Craig was showing. But anyway, Carl, is it?
Yes.
Yeah.
Hi, Carl. How are you?
Doing very well.
Excellent. So I have some presentations that I'd like to share with you. Just give me a moment and I'll get to them.
Thank you for coming on for your expertise again, Tony. I do appreciate it.
No problem.
Thank you guys in the chat for being so generous with super chats and memberships as well. Absolutely amazing as always. If you haven't already, make sure you're subscribed, like the video, share the video with your friends. Most importantly, share the video with your enemies. Because, you know, face palming and all that. Okay.
Okay.
Yeah, right. Whenever you're ready, Tony.
Yeah, when I'm ready. All right, just a second.
And the George said, has been a member for 9 months, says, I, FTFE, frankly the foot enjoyer, formally announced that all proceeds from this video will be donated to George without donuts. Dude, I'm on a cut. Why are you talking about donuts? That's just mean.
Okay, so I'm sharing.
Yes.
Can you see that? Okay, so so if the Earth were flat and we had an earthquake, then the energy from that earthquake ought to just radiate away from the point at the center of the earthquake, and maybe it'll hit the edge if there's an edge, or maybe it'll go on for infinity. But let's examine what shouldn't happen. What shouldn't happen is that the energy radiates out to a point opposite the Earth, opposite the epicenter, and then come back around towards it. But that is actually exactly what happens with every earthquake that we can detect. So this is the observational data from the Macquarie Rise earthquake. We're a little bit after the beginning. I'm not sure. I think this is the wrong version of my presentation. So let me just get the correct version.
That's right. J Gill 42, member for 10 months, says hashtag feed Rubiks. They had their bread and water allowance this month. If they've eaten it all already, that's their problem. Emerald Light Allowance Transit for 199 says, Tom, smooch all these doubters for me. Is that one of your friends, Tom? Carl.
I'm sorry, what was the comment?
From Emerald Light Allowance Transit, says, Tom, smooch all these doubters for me.
No.
I don't know who that is, and you said to call you Tom at one point. So, thank you, Emerald Light Allowance Transit.
Okay, found it now, so I'm starting the share again.
Okie dokie.
Okay, but so we've got a clear image of what should happen if the Earth is a plane. In other words, the earthquake should spread out like ripples in a pond, and maybe they'll meet the edge of the pond and bounce off that. But what would happen if the Earth were a sphere? And I'm not going to assume anything. Okay, this is our test. We're trying to test whether or not Earth is spheroidal or not. So if we have an earthquake where the vibrations reach the top here, the epicenter, what we would expect is for the vibrations to spread out, moving away, and then they go into the opposite hemisphere, and then they converge on the point opposite, right? Do you agree that that's what you'd expect?
Okay, let me just hear your model one more time here. So,
okay, so we started with our earthquake. We've put it at the top for convenience. We're just saying, look, the energy is going to spread out. If you look at that top left, you're going to see that it's spreading out in a circle. Okay, it's just spreading out, viewed from the top of the sphere, it's just spreading out in a circle. And then it's going to go into the opposite hemisphere, which is in the bottom right, and you can see that it's converging in a circular path, right, on the point opposite. That's what should happen if you've got a vibration on a ball. We can test this. We can actually test this in the laboratory, right? We can go into the laboratory. We can actually put a vibration source at the top, and we can look at how the ball responds, right? And this is what we see. Okay.
okay.
Does that seem physically plausible to you?
Yeah, I mean, it seems proven. I basically, just to make this palatable, so basically your earthquakes occur subterraneally, so impact at the top level expands like ball, dissipating the entire way and then reconvening. Yes, I get
yeah, okay. So now we're going to look at an example, and this is the Macquarie Rise earthquake from 2004. We're starting, so the epicenter of that earthquake is the red star. Okay? The blue circle is a seismic station in New Zealand. I suspect that's Wellington, where the signal has just been detected. This is at 3 minutes. That time up here, this is 3 minutes after. All right, and we're going to just step forward through time. In we're going to keep on going forward. Okay, you can see that it's arrived in Melbourne, or we're just going to keep on going. Sorry, my software takes a while to sort of get high resolution. But okay, so at this point on the left, that's an azimuthal equidistant projection that's centered over the epicenter. And you can see that the waves have gotten about halfway across Antarctica. They've gotten to the South Pole. On the right, we're looking at an azimuthal equidistant projection that's centered on the North Pole, right? This is geometrically, this is the only flat Earth map that gets distance from the North Pole correct for all. No,
I understand. Yeah.
Yeah. Okay. And you can see that the energy isn't circular, right? On the left-hand side, it looks like it's roughly circular. We'll see better evidence in a little while. But on the right, it's already sort of distorted. It's skewed. It's not spreading out in an even fashion. And we're going to keep on going. Okay, here we are. So we've gotten to the bottom, to the end of the Antarctic Peninsula here. And again, on the left, it still looks like it's spreading out in a circle. But on the right, for some reason, it's gone really quickly around the edges, but it hasn't gone across the middle. So something's really wrong with, that requires a really unusual seismic structure just to explain this one earthquake. But there are tens of thousands of earthquakes that we've analyzed, and we always get similar results to what we get for this one, which is to say that if you look at it in the azimuthal equidistant above the epicenter, it seems to spread out in a circle. And that's going to become more clear in a little bit when the signal actually meets the North American California has, heaps and heaps of seismometers. So you can see the circle shape. You can see that the energy is spreading out in a circle. Okay. More interesting is what's happening on the right. Okay. You can see that actually it's starting to shrink in a circle. It's also in a circle. It's starting to shrink in on that point opposite the epicenter. Remember what we said, that it should spread out from the point immediately above the earthquake, and then it should converge on the point opposite. So now we're going to keep on going forward in time. Okay, now we've entered what's called the P wave shadow zone. This is there's going to be a gap here for a little while. And this is because Earth has a liquid core, which makes waves very, very slow. So there's a gap here.
Where is the gap that you're identifying?
So you'll see that it's a gap in time. Okay, so here are some arrivals. They're the blue circles. And that's 1,035 seconds. Okay. And now we're going to spend a little bit of time, 1,095 seconds. So we've gone a minute and we've got no new arrivals. There was an arrival there, but it's a fairly generous one. Okay, we're still going. For some reason, my computer has decided not to listen to my keystrokes. All right, let's. 11:55, 11:70. Okay, and at 1200. So now at 20 minutes afterwards, we're suddenly getting arrivals, right? And that indicates that these waves had to go through an area where the wave velocity was very, very slow, much slower than the rest of the world, right? That's why there was that huge gap in time, before these waves show up. Okay, there's a little bit more. We can go. So this is if you just plot up the arrival times of the different waves, you'll see that they curve down. On the bottom is distance from the epicenter, and at the top and the vertical axis. Sorry, I'm gesturing with my hand like that's many people. This vertical axis is the time after the earthquake, and this is the distance from the earthquake in degrees. And you'll see that these curve down, right? So the further away you are, the faster the wave seems to have gotten there. And that makes no sense on a flat Earth, because the further away, the further, there's no reason for that. But on a spherical Earth, it does make, because the further you are around, the shorter the trajectory is, right? So you don't have to travel all of this distance, you're traveling that distance. So it's not that the waves are moving faster, it's that they're taking a shortcut in a sense, though they are actually moving faster because they're staying at depth longer, which means that because they're at depth. Now we're going to look at a particular type of wave, and you'll notice that there are particular types of waves here, these waves over here, that are very linear with time, right? So it looks like there's a straight line here and these waves are on it. These are surface waves, and they do travel around the surface of the Earth. So if we looked at the Earth from side on, here's an earthquake. We're going to look at the waves get to the surface, and they're going to stay near the surface. And the blue one's going to go clockwise, the red one's going to go anti-clockwise. And so we step through this and we receive them. These are called Rayleigh waves. These are the particular surface waves that I'm interested in. And this is their first arrival. And then they go past, and there'll be other receivers that will also pick up these waves as they're traveling along. And then they go around to the South Pole, and they don't stop. They keep on going. And then this wave, you remember this wave went through, and we had detectors all along here, and they picked up this wave as it was traveling. Now these same detectors are going to pick up this other wave as it comes back. And so it's going to come from the opposite direction, and it's going to hit our receiver again. That's the second Rayleigh wave arrival. Okay? But it doesn't stop. It doesn't stop again. Sorry, I was too quick. That first wave, the one going clockwise, that comes back. That's our R3 arrival. And then it goes round again. And it comes the R4 arrival. Now, this behavior, which is inconsistent with a flat Earth, even if we allowed that it was reflecting off the flat Earth, the return time of the Rayleigh wave would depend on how close you are to the boundary of the flat Earth. It would not. It would behave systematically differently than what we're seeing. The same behavior of emanating out from a focus going around the Earth, that's also seen in volcanic eruptions. Here, for instance, you may remember the Tonga volcanic eruption. This is just a graphic of the pressure wave heading away from Tonga, and that pressure wave goes on for days. I need to update this because there's a guy in the community who did a really, really good animation of exactly what's going on with this Tonga data, because you can track it using satellite data. You can see the pressure waves sort of moving around, and you can see it go from the volcano around to the point opposite the volcano and then come back. And you can see it do this through multiple circuits, right? So would you agree that this is very difficult to explain with a flat Earth model?
So, not entirely, to be completely honest. it's difficult without being able to manipulate the image, but if you had on the azimuthal projection that you were showing earlier, if there was a perimeter ring, I almost feel like that would look very similar as it folds out and comes back inward.
Would you? So, no, it wouldn't. And again, so we observe. So for this case, let's look at this case. For you, let's look at things returning back from this. No, that in that case, the perimeter would have to be here, right?
Correct.
But if I have an earthquake in a different location, then the perimeter has to be in a different location. But the perimeter can only be in one location. Also, we can detect whether or not waves have reflected off a solid surface. If that had happened, we'd see a change in the character of the waves. So no, that explanation isn't going to make any sense. And I would invite you to imagine that there are people who spend their entire professional careers analyzing earthquake data. And they develop flat earth models for analyzing seismic data. This is done because we use seismic data in industrial exploration applications, and flat earth is just easier, right? So I myself worked with some flat earth seismic models. I adapted them into a slightly different modeling framework. So we have flat earth seismic models, but they don't fit. And in fact, we've done studies on how they don't fit, where they don't fit, and why they don't fit. You can't make flat earth seismic models fit general data.
Because Earth's not flat.
I don't know why reverberating off a perimeter, we don't know. This is all assuming a uniform, well, not even a uniform density, but it's assuming the internal density of the Earth, which...
No, it's not. There was no absolute... All I showed you was observational data. I didn't show you any modeling data.
I mean, this is a model.
Yeah, but it's a model that can only happen if the Earth's a globe.
No, it's not. It's a plot of observational data.
Yeah. Which could only
you're
match
describing a model. You said this occurs across thousands of earthquakes. This is one observational data. I understand what you're saying, and from a picture...
Do you not think that there are tens of thousands of earthquakes every year?
I'm sure there are. I'd like to see more to confirm.
Okay. So this data is publicly available.
Okay.
Can I ask exactly what's going on here? Because you're sitting, you've pulled back from the camera, you've crossed your arms in front of you, so you're in the process of physically and mentally disengaging from the discussion because you find this threatening. That's how it comes. No,
it's honestly not threatening. I didn't know this was a discussion about body language, but if you like, I can stand at attention for you.
But this is not designed as one of the things that makes conversations about flat Earth difficult is that many people make it part of their identity, so that if we have a discussion about the data, it feels like they're the person under attack, like they're being criticized.
I truly don't believe I'm under attack, and I stated at the beginning I was extremely open to any compelling information. This to me, I understood what you were saying immediately. It seems
I have a bad reputation for getting angry at people, and I'm just trying to check that I'm not coming across as overtly hostile.
I could not feel less offended by being shown a map of earthquakes.
Okay, all right. No, the question was not about what I'm doing. The question is about how I'm behaving, because sometimes I come across as very hostile to people, and that's not my intention here. Okay,
Only
I'm not trying to attack you. I'm not trying to attack I'm not trying to say you're stupid or ignorant or anything.
I mean, I get told I'm stupid every day. I mean, everyone says it's a stupid theory. Here we are having a discussion about it. I think I'm open to a little bit of a different interpretation of that model. I would need to see more repetitive data to make a firm discernment. I understand your initial ball and epicenter and anticenter diagram. That all makes sense to me. I don't know without but I was stated earlier that there was an assumption of uniform density of the Earth. Without that information, I don't know on the an FE model if the thickness of the perimeter is lighter, if that would affect the wavelength. I don't have, a PhD in seismology. I can only go by estimation at this, and you're being the expert.
People who do have PhDs in seismology have attacked these problems. Right, they have looked at the questions you're asking. Can you make, what is the largest length scale on which you can make a flat Earth model accurate? That's a very important question in seismology, so we've looked at it. I say we, I'm not actually a seismologist, but people in seismology have looked at sort of what's the length scale over which you can treat the Earth as flat. You seem to be saying, look, somebody could come along and could ask these questions. They've been asked by people who are very knowledgeable in this data, and I understand that you're you have a natural disinclination to listen to somebody else when they're just because they say so, and that's reasonably healthy. And the idea of flat Earth being stupid, only sometimes. What's your? I missed the early part of the debate. What do you do for a living?
I'd rather not discuss that. But
okay. Would you consider yourself mathematically literate?
Yes, I have a degree in economics, and
okay.
So
if I asked you what the cosine law was, right? Would you know off the top of your head, or if I told you that if I knew two sides and the angle between them of a triangle, I could calculate the length of the third side?
Yes.
Does that ring a bell?
Yes, I said yes.
Yeah. Okay. So, but doesn't that mean that I can develop a flat Earth distance formula if I've got 2 points of known? Maybe I'll share my. Can I share my screen again?
Yeah, please go ahead. I was gonna.
Yeah, just
want to say thank you for the 25 members, NA for bacon. The 20 members, sorry, I really do appreciate it. It does not mean that I add an hour to the stream. That was last weekend. They made me go for 80 hours, Tony.
Yes, there was a spectacular display of sadism.
Yeah. I mean, I'm not sure if it's love or hate or a bit of both. I'm not sure. I feel conflicted.
Okay. So let's look at the where are we here? Okay. So we've got two hypotheses, either it's spheroidal or it's planar. And so let's assume that the Earth is spheroidal. This is an assumption. We're just making the assumption. So so if I know the latitude and longitude of 2 points, I know their distances to the North Pole, and I know the angle between those two arcs. So I can solve for this distance, right? This is using this. And that's the solution there. This is called the spherical law of cosines. Okay, it's a few hundred years old, and so from that, if you wanted to demonstrate that the Earth is not spheroidal, you could get any 2 points on Earth of known latitude and longitude, and you could show that the distance between them is not well approximated by the spherical formula. If you could do that for any 2 points, and there are infinite pairs of points, if you could do that for any 2 pairs of points, then you could show that the Earth is not spheroidal. there's no limits on any location, any two locations on Earth with known latitude and longitude where the distance is not well approximated by the spherical distance. So the Earth being a sphere is absolutely falsifiable. You can go out and test it yourself. You can also solve for the bearing. So not only can we solve for the distance, but we can tell how far from north we have to be. That's given by this formula. So if you can find any 2 points where this is not the correct bearing to take, you'd also have falsified flat Earth. So again, if you're at a distance from the ground point to a celestial object, you know the distance between those 2 points. So yeah, so that's another way. But we can turn this around. We can say, what if the Earth is planar? If the Earth is planar and we know the latitude and longitude, we can work out the distance to the North Pole. We know the angle between the two lines, so we can calculate that distance between those 2 points. And that's just the planar law of cosines. So this is just the law of cosines. It's about 2,300 years old at least. Okay, so that also gives us a falsification. So we've made no assumptions other than that the Earth is planar and that we know the distance to the North Pole and that we know the angle between two meridians of longitude. Now we can test this. So we're going to test it on Pensacola to Jacksonville. There's a train line between them. It's actually not in use at the moment. I think it was damaged during Hurricane Katrina. I could be wrong. One of the hurricanes sort of washed it out. Anyway, the spherical distance between these 2 points is 533 kilometers. The distance along the track is 593 kilometers, and the flat Earth distance is 643. That's physically impossible. The flat Earth distance is physically impossible. That distance is the minimum distance, the minimum track length between the track length can't be shorter than the distance, right? So we can take another example from Australia. We're looking at Tarcoola and Kalgoorlie. The spherical distance is 1,242 kilometers. The track distance is 1,281 kilometers. Flat Earth tells us that the distance is 3,000 kilometers. So the flat Earth approximation is in error by 150%. These are just some, and you can measure this, right? We know how much track we used. We can surveil them. This data has been in place since the early 20th century. Also, if you're skeptical, you can actually buy a video. There's a television series where they strap cameras to the train so that you can watch the train make that journey. I don't know why this became popular in television, but it worked. It worked for a railway thing called the GAN. So they decided that they'd do it for the Indian Pacific. So if you wanted video evidence about the track length and how long it takes to get there, we've got it. You can also do the same this is in Argentina. Again, the flat Earth distance is in error here by 800 kilometers by 200%. This sort of thing. Craig was talking about how this sort of thing works. When Captain Bligh was thrown off the Bounty, the first that red star there is where they started. The first point where they landed, they got attacked and one of their crew members was killed. So they decided they decided they had to make the rest of the journey while making as few landfalls as possible. So they had to work out how far they had to go, what direction they had to go, and whether or not they had enough food and water to get there. And they barely did, but they made it. And on the right there, we've got Bligh's logbooks. We know the calculations he did to work out how far he'd traveled, where he was, where he was going, and all of that uses spherical trigonometry, right? Again, the total distance that he traveled was about 6,000 kilometers, but it's 5,600 kilometers in a straight line. Sorry, it's 7,000 kilometers. I'm wrong. But the flat Earth separation between those 2 points is, again in error by 50%. Another example, the Shackleton expedition, which got stranded in the ice while exploring the Antarctic. They eventually made it to Elephant Island, and they sent off their little rescue crew. You can see them off here. They're in this little boat. They're going to go and get help. They had to travel across the Southern Ocean in winter, which had never been done before, to get to South Georgia Island. Again, the actual distance that they traveled was about 1,300 kilometers. You can see here that they travel north-south, and then they go west to east, and they sort of did that zigzag thing a little bit because it was very stormy and very rough, and they wanted to sort of come there's about 5 miraculous things that happened here, but they eventually got there, and nobody died. So there are thousands of marine journeys every day that use spherical trigonometry and spherical geometry. And we've been using spherical geometry since the 17th century. This is from the Mariner's Magazine by Captain Samuel Sturmey. This is about how to get from the mouth of the Amazon to the Scilly Islands. This is just a navigation exercise in spherical trigonometry. Similarly, plane journeys. So here are 4 plane journeys. I've taken the outbound and the inbound. Over here, how long these flights take. So by taking the outbound and the inbound and averaging them, I'm kind of getting rid of the winds, because the winds are going to even out between the two. Now I'm just multiplying that by the cruising speed of the altitude. I'm not giving them any time to accelerate. I'm not giving them any time to maneuver when they're near the airport. I'm just saying, okay, we're multiplying that time by the cruising speed of so this should be an overestimate of how far they are.
And I'm sorry, just to clarify on this, you said you haven't actually taken these flights though, correct?
No, I haven't. Okay. Brisbane to Dubai, actually, I think I have. Yeah, Brisbane to Dubai, I think I have.
Which would be essentially linear on a.
Well, the flat Earth estimate for the distance between Brisbane and Dubai is in error.
I think I'd remember going on that plane, Brisbane to Dubai. That's quite a journey.
It is a journey, but I was sort of. The thing is that Dubai wasn't my destination. I was going to Europe. So I can't, and there was a stopover. I can't remember if it was Dubai, or some other aircraft hub in the Middle East. So I wasn't headed to Dubai. I was on my way to, I think, Frankfurt. Well, actually, I was on my way to Milan.
Okay, that's fine. I just wanted to clarify that you had actually taken the flight.
Yeah, so I had taken that flight. Anyway, we've actually got video footage from this flight up the top, Santiago to Sydney. So a critical think. Do
you have any of the flight paths associated with these? What that would look like?
I mean, they're this particular one, sort of, I can show you down here. Actually, it would look like this. It goes down like that.
Okay.
So,
where we're flying from Sydney to Seattle?
Sydney to Santiago, which is in Chile. I think it's around about there. It's where my cursor is. Yeah.
Right. Yeah. Okay. But.
So we go south in order to get there. Pardon?
I mean, this graphic is not the flight path.
No, this graphic is not the flight path. Yeah. This graphic is actually a map of the submarine cable from Sydney to Seattle. Okay. So this is a physical object that carries internet traffic from Seattle to the spherical distance. is 12,000.
99% of all communications are submarine sea cables.
Yeah, we've always
Right.
no one's ever said that it's from the satellites. That's only kind of modern internet like Starlink.
Yeah.
Well,
But
the
but
submarine internet cables were derived back in teleprinters. They've always used undersea cables.
Yes, they've always used undersea cables. I think you're missing the key element that the length of that cable would be in error, the actual length of the cable. And again, somebody went out and laid this cable, and this cable costs millions of dollars per kilometer. So if the cable is actually secretly longer by about 2,000 kilometers, then somebody is out, the best part of $1 trillion.
Well, I mean, when you're talking about something obviously this incredibly large on scale in terms of what the cost of deception would be, that's essentially trivial to a group that does already have all of the money on the
Well, but we can test the length of the cable. We can send a signal down it, reflect it back, and see what the latency is, right? So we can test how long it takes to send a signal down the cable, right? So the latency is about a millisecond per 1,000 kilometers or something like that. So
when you're using this flat Earth distance, that is on the projection map, correct?
I didn't actually introduce a map. I introduced this formula.
I mean, what are you deriving this flat Earth distance from then?
This formula on screen.
Can you see the slide that I'm showing?
Yes.
Okay. So I know the latitude and longitude of these 2 points. From that, I calculate the distance to the North Pole for each of the 2 points. And the angle between them is just the difference in longitude. Now, you can say, I disagree. I don't think you know the distance I don't think you accurately know the distance of these points from the North Pole. I think you don't know the longitudinal difference. This one I can disprove. I can prove that if you move directly north towards the North Pole, then mathematically you are on the same meridian. You haven't moved east or west, so you haven't changed this essential angle. So mathematically, this one is not an assumption. This one is something I can demonstrate. But you may say these distances are wrong. In which case, I expect you to be able to prove it. I expect you to be, because when we do observations of how much distance is traveled when you go a degree north or south, we always get that it's about 111.2 kilometers. And we've done a lot of research into whether or not that's true and how much it varies from it. So if you're going to say this isn't actually the distance to the North Pole, you're going to have to provide some proof, because I'm under no obligation to believe you otherwise. But that and planar geometry are the only assumptions that have gone into my flat Earth distance formula. You said you were mathematically literate, so you know that I can't jigger the maths here. This maths doesn't have any free parameters that I can manipulate. So you know that the only assumption is that 1 degree in latitude is approximately 111.2 kilometers. That is the only assumption that's going on here, and most flat earthers concede that that's true. Are you disputing that?
No, and I mean, I would. I mean, there is some conjecture that the longitudes are larger below the pole, so that could be a variable factor. I understand this formula you've displayed, so the distances would most likely be the item in question there. Obviously, I can't prove it. I don't have, a measuring tape that would extend that far. So we are going
measure
just
about
by
measuring tapes, though, right?
previous records by map makers that, same way that it's been transposed over this amount of time, I can't physically prove it. And I
But
mean,
you
the thesis
can
would be
measure the
that we
length
don't
of a
have the
railway
satellite.
track, right? You accept that we can measure the length of a railway track, right? That's a physical object made of
Right.
metal whose length we can determine, right?
That's, yes, I understand.
Okay, so my examples here of railway tracks, and this one is particularly important because the flat Earth error was 150%, right? The flat Earth isn't even close. It's not in the right ballpark.
Okay, so let's go back to let's look at the one in Florida then.
Okay, the one in Florida, where the error is only 12%. So
Okay.
No, it's
well, that's
like-
a vastly
it's-
different percentage. I do think that there is a larger discrepancy with measurements in the southern hemisphere for sure. I guess I'm struggling where this flat Earth distance, your spherical distance, is that accounting for the additional length that would be due to the sloping, correct?
Yes.
no,
Well, it would be, right?
No.
Well,
no, I'm just that spherical distance is just the shortest path length along the surface of a sphere between the 2 points.
which would be curved, obviously.
Well, it would be curved, but I thought he was talking about track, whether or not the track is going up and down hills.
No. I
No,
don't think so.
no.
Okay, so
Which,
yes,
I mean, could be a variable factor, but
but and that explains why the spherical why the track separate what I've called track separation. That's actually the wrong term for it. It's the along track distance. It will always be larger than the spherical distance. The spherical distance is sort of the minimum distance that it can be. But because you'll see that this isn't directly east-west, that it curves a bit. It also goes up and down elevation. So the track is always going to be longer than this minimum distance, right? That's to be expected. And it occurs all the time. So that track is longer than that spherical distance. But what can't happen is that the minimum distance is longer than the track. Okay? That can't happen. That's geometrically impossible. This is the shortest distance across a plane between these 2 points, and that can't be longer than the track. So this single result, even though you're saying like it's a smaller error, it's still an error. It still falsifies the claim that the Earth is planar, right? So this is a direct observation, a direct measurement that tests spherical Earth versus planar Earth, and planar Earth fails. We can discard planar Earth. It's not, this is how science works. You look at the two hypotheses, you don't make any preferential assumptions for one or the other. You compute the consequences of the hypotheses, and you compare that against observational data. And I mean, like, we could go with, the rate at which winds travel, or the rate at which weather systems travel, or the rate at which tsunamis travel, or the rate at which hurricanes travel, and we'll always see that those rates, when we measure the wind distance on the ground, and we say, well, how long, for instance, does it take a balloon if we release it here to go over there? We always get confirmation of the spherical distances. So but if the Earth were planar, shouldn't we be able to demonstrate it? Shouldn't we get results that where the planar fits much better than the spherical distance? Right? Isn't that what you'd expect?
yes, absolutely.
And that's what
Okay,
I was saying. Like, that's why all measurements ever, including calculations, like everything that Tony showed you, everything matches the globe. There is not a single measurement ever done by someone competent that shows that the Earth is flat or stationary. That's why.
Can I say something? Can I
Yeah.
say something here? It's not stupid to say, look, the stuff I was told in primary school is not actually convincing evidence. That's not stupid to say. It's not stupid to say I've not come across evidence, the convincing evidence that the Earth is not flat. That's not stupid to say either. Okay, so nobody's calling you stupid. Nobody's calling any.
I mean, you can call me stupid. That's completely fine.
I'll wait till you do something that I think is actually stupid before I do that. Because I won't hesitate if I think you're doing something stupid to tell you that, to voice my opinion on the matter. But it's perfectly okay to go, okay, looking in detail at this stuff I was told when I was a primary school student, that isn't a strong argument, and that's okay. But there are people called geodesists who study the shape of the Earth, and have dedicated their entire careers to it, and they've developed stuff like GPS or Doris or very long baseline interferometry, stuff for precisely calculating distances on Earth, so that we know how much you move during an earthquake, whether or not you're undergoing uplift during an earthquake or whatever, so that we can understand the dynamics of the Earth and we can better understand earthquake risks and how to mitigate for it. Like billions of dollars of infrastructure and millions of lives depend on us getting these things right. And that's why people throw research money at it. But they'd have noticed, right? They'd have come across it. And it's not your job. A lot of flat earthers get into this because they see a flat earth video and they go, well, that should be easy for me to debunk. That's not your job. You're not a geodesist. It's not your job to debunk flat earth videos. There are people whose job it is to demonstrate the shape of the Earth who can debunk those videos, but they're busy doing something else. They're busy actually pursuing their careers, and they don't give, forgive my language, a flying fuck what some idiot on the internet thinks. So they don't bother to, they generally don't bother to come down and explain in accessible terms the evidence that's available that allows us to show Earth isn't planar and Earth is approximately spheroidal. So don't, it's not stupid to say, look, I'm now skeptical of the stuff I was taught as a primary school student. Okay, fine. But what you should do then is actually go to the literature that has been prepared by people who are experts who actually get paid on results. Shouldn't that seem reasonable?
Yeah, absolutely. It does. It seems like taking a lot of evidence by faith, though, unless there's a provable test, and I understand they're incentivized to do their jobs correctly, and I completely respect that. The locational data, it just seems too grandiose to take by faith, though. I can appreciate your models. Mathematically, it's sound. It's just the locational data seems it's at a scale too large to independently verify. And I don't know. It's not a singular measurement. It's a composite of measurements. When you're judging the distance between Sydney and the North Pole, that's a composite of measurements. There's no
all
singular...
measurements are calculations, to be fair. So
exactly, it's a calculation. That's
but all measurements
exactly.
You can't do measurements without calculations.
But
you can
isn't that
estimate.
But don't we just need to do it one bit at a time? So instead of the distance from...
Well, that's why I was focusing on the Florida.
Yeah.
It was a smaller scale. It was more palatable. And
Yeah.
I understand what you're presenting that as calculated data, but track length is subjective. I mean, even by terrain, and I understand what you're saying is that the planar distance should not exceed the track length, which, correct, it shouldn't. That doesn't seem possible. If the 2 points do connect by track, it should not exceed that distance, 100%. But it is still an approximation.
No,
It's
an
estimated calculation of
No.
distance and applying that.
It's not an approximation. No, the minimum distance is a mathematical. Mathematically exact. Given it's mathematically exact to the precision that your latitude and longitude. Any imprecision in the latitude and longitude will turn into an imprecision in the distance, but it's only mathematics that links the two. There's no the mathematics itself is not imprecise.
No, it's not. The model is sound. I agree with you.
So, and this is one of the frustrating elements to me about flat Earth is I have an enormous degree of skepticism about professional politicians and their agendas and the way they lie to and manipulate the public, the irresponsibility of the media in not properly deconstructing when somebody just gets up and spouts bullshit, and the fact that media are owned by large corporations that are profiteering from the control that they exercise over the media. And we could be having
we can foundationally agree upon.
And we could be having a constructive conversation about how our society needs to be reformed in order to address these incredibly dangerous and sinister forces that are undermining and destroying democracy and are acting to harm individual voters. But instead, we're here talking about a scientific question that has been settled for literally hundreds of years. And so I understand the spirit. I understand the spirit of I don't trust authority. But there's literally, in this case, there's very little scope for them to, there's a bunch of independent academics who would love nothing more than to prove every other academic on the planet wrong. That's the ultimate dream. The ultimate dream of every academic in their field is to say, hey guys, here's the actual data, and you guys have been wrong the entire time. Now, in order for your conspiracy to work, either all these guys are in the conspiracy, and you need to ask yourself, would you be willing to dedicate your entire career to just lying to people casually on the internet for money?
Well,
because I wouldn't.
Okay, well, that makes you better
How much
than
money?
the majority of people, and that kind of counteracts with what you just said about what you claim to know about the government. And obviously, there are people.
I don't
who
work for the
betray-
government. But the academics don't work
I'm
for
not
government.
accusing you of working for the government.
But the academics who analyze GPS data, the academics that analyze seismic data, they don't work for governments.
Okay.
So
You're asking how a misinformation campaign at that level could exist.
Yes.
Okay. So the answer to that would be your previous statement about why the government even produces misinformation. I mean, I don't want to get incredibly political about it, but there are absolutely incentives at the highest levels of the government to provide information, whether it's financial or there's something more to it.
Yeah, but academics aren't in government, so you're explaining why government might do it, and I would argue a lot of people who are anti-government are pro-business, but I would argue that there's every incentive for corporations to lie, cheat, and demean, and the only way to protect individuals is when there is balance between corporate and government interests. So the small government argument.
Definition of fascism is the
What?
blending of government and corporations.
No, I didn't say blending. I said in balance. They're not cooperating.
Working in coercion.
They're opposed to one another, but they're equally powerful. So the government can't just overwhelm corporate and private interests, and corporate and private interests can't just buy out the government. And I think that's the problem that America is facing at the moment, is that it's too much in the corporation's favor, so that wealthy trillionaires can come in and decide, here are a bunch of programs that are actually keeping people alive, but I'm going to make political capital by dismantling them, along with all of the regulatory mechanisms that stop me from doing illegal stuff. So
So
there's
I can respect that sentiment completely. I do think that it is beyond blending at this point, that governments and corporations are one and the same. And
and
I
they
would
need to.
argue that honestly, as much as you'd like to believe it's not, academia is also intertwined in that, where governments are being paid for by corporations. America is a corporation. We were founded as a corporation. And we use the tool of academia to perpetuate that by, holding lordship almost the same way that
To be
the Bible was
to be
only written
brutally
in
fair,
Latin
so
to keep
how many academics do you know?
few.
Okay. Are they, in your opinion, are academics profit seeking, or could they earn better money by not being academics?
Well, the money is in the academic achievement, which it does not benefit you
Yeah,
to
but
go against
once
the
you've got your
status quo.
PhD or whatever, do you get more money in business, or do you get more money by being an academic?
Well, you write the answers that the corporations want. That's how you get more
That's
Not
money.
if you're
not
an
what.
academic, you don't.
I struggled to wrestle that concept.
Right, well, let's not go down
But
a different rabbit hole.
So academia is characterized by publish or perish, but you can't publish if all of the other academics are going, that's bullshit, and I can prove it's bullshit, right? Your academic career is not going to flourish if you are demonstrably wrong. Now, don't get me wrong. There are people who luck into sinecures. A lot of climate denialists get sinecures at universities because mining corporations say, you're going to hire this person, or we're going to send our mining engineering students to another university. That happens, but in general, but they don't publish, right? They just publish opinion pieces. They don't publish academic works. In order to publish something in academia in an academic journal, it has to pass peer review, and then it has to not be torn apart by other academics who really want to big note themselves, to aggrandize themselves by ripping other people's work apart. So I don't think you seem to have this idea that academics are in it for profit. If they were profit seeking, they wouldn't be academics in the first place. They'd be out working in corporate gigs.
All right, I want to start wrapping this up for tonight. Tony, I want to say thank you for your expertise as always. Carl, what are your general thoughts on all the evidence that he's presented? Just any quick comments before we start wrapping things up?
Yeah, I mean, it's definitely interesting. I'd like to look more into the locational data. I think there's a lot more to be done there. As far as what I spoke about with you, I would love to put together a few of those clips that I was talking about and probably do a better job of laying those out. But it's interesting information. I'm also going to look into that LIGO. That I think was the most compelling thing that you brought up. We're definitely going to do a little bit of research on that. I am slightly more convinced in your premise. So again, I was intentionally hoping, there'd be something that would, knock it out of the water. There's data. I personally think there's data on both sides. I think there's a lot of fakery with the ISS, the Apollo missions. I think there's just almost too much coincidental inconsistencies with a lot of the space information, a lot of the footage we've been shown, a lot of the stories. There's quite a bit, I think, that still needs to be unpacked there. If I were to believe any of it, I don't.
Well,
believe
just
the
focus on
ISS.
the data.
Why is that related to the shape of the Earth?
Yeah, that's just focus on the data we've shown you that shows the shape of the Earth, and then once you know the shape of the Earth, then look at the other stuff.
So the nothing I showed you, the earthquake data, the distance data, the train data, the plane data, the shipping data, the submarine cable data, none of that is related to space missions or NASA. So can I not claim that I've demonstrated the shape of the Earth and I've not relied on NASA at all?
Well, not particularly. I agree with your model. the way it was described, I don't necessarily trust the locational data unless you're using NASA by satellite. The rest of
you
it
trust
is a
NASA, okay.
compilation.
You're claiming you can't work out your position by anything other than satellite.
Not without a series of calculations.
Well,
again, all
yeah,
measurements
but
are
you understand mathematics, right? So calculations aren't a black box. They're not magic. You can't
Well,
just
if you're using
magic your
longitude
location.
and latitude, I don't think there's enough credence in the locational data.
Well, how about I get
So-
Tony to send you the locational data so you can go over it yourself, and you can do a bit more research on other seismic events and stuff as well, instead of just going round in
I
circles
can just
tonight.
give you the data itself comes from Iris. I'll just get that up. It's the International Research Institute of Seismology.
And before you go, Carl, Jolene has an important question for you. Pineapple on pizza, yes or no?
What was that?
Pineapple on pizza, yes or no?
Pineapple?
On pizza.
Oh,
Yeah, yes
I
or no?
like it.
You like, okay,
I
no.
haven't had it. I don't eat pork, but I used to like it back in the day. But yeah, it's just, it's nice because the little citric hit, it's whatever.
No, it should never be on pizza. Bad. Magical
I
Cat
have to
Girl.
admit, I'm not a pizza purist, which is going to disgust some people. Despite having lived in New York State for a little while
Ooh.
in my life.
Yeah, like there's some weird kind, like a fig almost sometimes where there's options out there. It's yeah, I'm not a huge pizza.
Pepperoni and anchovies and mushrooms. That's all you need on a pizza. Magical Cat Girl's been member for 3 months. Says Australia people, remember to do your census tonight. Don't want the ABS coming for £364 a day fines for not doing it. Yes, tell the government everything. Jim Daniels, $50, says hashtag feed Rubiks is now trending on the FTFE channel. It can trend as much as it wants. They get fed when they do as they're told, which is make shorts. NA for Bacon, been a member for 7 months, says hi and then gifted 20 memberships. Thank you very much, my friend. Goofball Turbo, 199. Where are both magnetic poles if the Earth is flat, Carl?
Where was what?
Where are both magnetic poles if the Earth is flat?
Well, there's only one magnetic pole.
No, that would mean a monopole. There's no such thing as a monopole.
That's absolutely falsifiable.
Yeah, there's quite clearly a north
Yeah,
and south
and
pole.
again, there are people who study Earth's geomagnetic field full time. Their careers, they've built their careers around it. We know.
That's the one where you have the circular magnet. It's got the central pole, and then it flips inward like that.
No idea what you're talking about.
A toroidal magnet.
Yeah.
All right. That's what I envision it would look like. So,
but there can't be a single pole. That's just impossible.
Yeah, I'm thinking
that contradicts your argument, because if that were true, the South Pole would actually be below Earth, wouldn't it? Well, so it would be underground. It wouldn't be on the surface, whereas demonstrably it's on the surface. Am I wrong about that?
Perimeter.
I don't think that.
Trust us, Carl. There's no such thing. Well, Panties 199 says, ask him the important question, and hashtag don't feed Rubiks. Okay, Carl, what's your favorite shark?
Shark?
Yeah.
Fuck sharks. Let's go with the great white. I don't know, man.
I mean, they're awful and terrifying. Hammerhead sharks for the win. NA for Bacon, $6.
If it really wants to go out, you won't even feel it.
NA for Bacon, $6.66. What? PhD Tony's never hostile. He is like a warm hug to all flat earthers. Avis64 has been a member for 66 months. Says last weekend was epic fun with friends. That was a lot of fun. Smashing my record by a good 8 hours. And then gives 5 memberships. Thank you very much. Smake Kai, $5. FTFE is kind and honest and smart. We need more of you, so clone yourselves before we have to. Good job resisting Carl's confusion ray. Grabies. Yeah, the Flerf confusion ray is strong. Aaron says for $2.99, can you produce any working flat Earth model? Carl?
Yeah. Well, I mean,
You can.
I mean,
Interesting.
the way I envision it, and I mean, it's not new by any means, but I tried to touch on it earlier. I was fresh on the mic. I was kind of stumbling, but I mean, circular plane, obviously. I believe that stars are luminaries, and I mean, to get into the rocks of it, I do think, and I didn't want to get religious, but water's above, so it's, deep ocean below. Plane, solid firmament. The sun and moon exist outside, but they are luminaries. Approximate local distance would be about 3,000 miles away. Appears much lower, moves in a circle, and it does have a slightly wandering path, so to speak. It's constrained, but it does, vary in terms of longitudinal circumference. So it'll move inward, outward, seasonally. As well as
Can I ask why you think that's a working model? Because as an economist, you should know that if a model can't make useful predictions, then it doesn't work, right? If you can't predict,
provable.
Predict the distance between 2 points on Earth for me.
I mean, I can only go by the data.
Yeah, there's no flat Earth projection that does that, right? It is mathematically impossible for there to be a distance preserving map from the surface of a sphere onto a planar surface. It is demonstrably, provably, logically, mathematically impossible for that to happen. So if the spherical distance formula is correct, and we've got no evidence is reasonably accurate, and we've got no evidence that it isn't, you've yet to provide an example, then Earth can't be planar. And if you can't, using a flat Earth methodology, produce a distance between 2 points, then your model doesn't work. It's not a working model. Furthermore,
I mean, you're saying that, but there could be a differentiation in longitude in the southern hemisphere. I can't verify that. I just have to go with what's provided.
In which case, there'd be a discontinuity in the longitude parameter that would occur at the equator, which we cross every day. That demonstrably doesn't happen. It is, as Clive Wells points out, it's topologically impossible. Topology being a part of maths. It's just you are.
What does that have to do with topology?
Sorry, I'm getting frustrated. You are asked about a working model. In order to, and then when challenged on distances, you go, oh, well, I just use the spherical distances. You can't use the spherical distances. You're supposed to be composing your model. Your model can't use spherical distances. It can't use spherical.
I trust linear singular distances. I don't trust composites.
I don't care. Well, yeah, but the rest of the world, everybody on a ship does trust the distance calculations and the bearing calculations. Everybody on a plane does trust the distance calculations and the bearing calculations. In order to know how much fuel the plane needs in order to get that far, in order to work out, do we have enough fuel to get to a particular airfield? All of these calculations use spherical distance formula. The direction that you need to go in to get from one point on Earth's surface to another point on Earth's surface, that uses spherical. So when you describe, when somebody asks, do you have a working model? What they mean is, do you have a planar Earth model that can do these tasks, that can undertake these things? And the accurate answer is no. You don't have a planar model that can do those things. You have a conceptualized model that when you squint at it, you imagine can do these things. And as somebody who works, I don't know if you're an economist now, but you claim to have training as an economist, you should know that an economic model that is, hand wavy and conceptual is not useful. You're going to lose money.
I mean, economic models in general are unuseful, so that's honestly a poor example.
No, there are a lot of for
Economics
instance,
is based on
microeconomics is very deterministic. So you can
slightly
and
more so.
it's not slightly, it's very much more so.
Slightly
And
more
you
so.
can well, you're assuming that I haven't studied economics, and I can tell you that you're wrong. There's a great deal of mathematical analysis. The key element, the key problem with economics is the assumption of rationality, and because not everybody is a rational consumer. You're demonstrating that right here. The rational response to being asked if you have a working model would be to say, no, I
I
don't.
interpreted that question as astronomical model. I did not interpret that as a distance model. I believe in linear distances. I've already said that.
Okay, so in science, a model needs to basically make predictions, and they have to be accurate. So, Mission Apparition Power has been member for 55 months. Says, hi, dude. Missed last weekend. Sorry, up south been massive. That's all right, mate. Thank you for all your support. Aaron, is member for 20 months, says, the way to get fame and fortune in academia is to challenge and prove the status quo to be incorrect. We always remember those who changed science. Yes, that's true. Sits and 9 member for 40 months says, can I change my vote? He's a goner. No, once you voted, it's locked in. Aaron, 299, explain the celestial South Pole on a flat Earth. How do you explain the fact that stars go the opposite way around the celestial South Pole than the North and the different stars, Carl?
Could you repeat that?
The stars go around a different point in the sky in the north and south. So in the north, they go around Polaris, and in the south, they go around the Southern Crux, and they go in opposite directions. How does that work if the Earth is flat?
I mean, it all goes in a circle.
Yeah, but it's two different circles going in the opposite way.
So you have a circle doing this?
You're muted, Tony.
Like,
So we're talking about clockwise versus anti-clockwise.
yes.
Do you understand? So, all right. So in clockwise, is my hand opposite on the screen?
I don't
I
feel so.
get what you're saying, yeah.
So, but they go clockwise. They go clockwise in the north. If you're in the northern hemisphere, if you're at the North Pole and you look up at the pole, the stars will be going clockwise, right? If you're at the South Pole and you look at the stars, they go anti-clockwise.
And that's
What do
because
they
you're on
do?
opposite
Equator
ends of a
don't
sphere
move.
that's rotating, east to west. So, based on which way you're looking, the stars will be rotating in an opposite direction. There's no explanation on the flat Earth, but it makes sense on the globe.
Well, you
So-
wouldn't even be looking at the same stars on the
Exactly.
southern hemisphere.
That's the point.
Yes,
How can you
you're-
look at
you're
two
not looking-
different sets of
So it's
stars and
a
have them
completely
rotate around
different
different
star
points,
system.
which
But
works
why?
for the globe, not
But
the flat
why
Earth?
does everybody in the sun? What causes them to go anti-clockwise in the south? And what
But are we looking at the same
around the
star?
southern celestial pole and clockwise around the north celestial pole?
Where do they go in the equator?
Both ways.
That depend at the equator. It depends on whether. It doesn't matter if you're looking at the north celestial
They don't
pole.
move?
No, if you're looking at the north, if you're looking northwards, they go. Sorry, I think I've got it wrong. If you're looking northwards, they go anti-clockwise. If you're looking southwards, they go clockwise. So when you're at the equator, it
degrees
depends.
south of the equator.
It
it's the same
depends on
thing.
which direction you're looking in.
So that's just a gradient.
Gradient of what? And it's not
The
a
more
gradient.
south I go, the more other direction they go.
So
which
this is what you see
No,
at
that's
the
not
equator.
true.
They flip.
The
It's not like
equator,
I
you see
walk
this.
across
and
Central
clockwise
America and they
and clock-
flip upside down.
So clockwise and anti-clockwise, there can't be a gradient. It's on off.
Yeah. Like, look at the
That-
picture on
Just
screen
excuse
now.
me,
That is fundamentally
At the
possible.
picture on screen now, this is what you see at the equator. We're doing a panoramic shot. If you're looking,
Okay.
if you're looking east here, to the left would be the north, and to the right would be the south. and they rotate different ways around different sets of stars.
So it's a gradient, like I was saying.
No, that's not what a gradient is.
So I mean, I wish you could speed that up or something. So
Well, that's a picture. You
on the
can't speed
left
up
side,
pictures.
this is the south. Sorry.
Yeah, on the left was the north, on the right was the south. But it matches the globe. It doesn't match the flat Earth. Bill Tetley, $5
so
says,
it's,
I'm Craig, and I want you to bring my new FTFE branded butt plug for my OnlyFans. The link is... no, Bill, bad. Julian the Inventor, $5. My name is FTFE, and it's my official opinion that the Star Wars sequels are better than Star Trek. You can get the fuck out right now. Smeek Kai for $5 says, make him say grabies. Carl, say grabies.
Send me $5, sure.
There you go, Smike. Goofball Turner 199. I have plenty of other simple questions next time. Thank you guys for the support. All right, Tony, Carl, I'm gonna stop it there for tonight because it's 20 to 3 in the morning here for me, and I have personal training in about 6 hours, so I need to go to bed.
All right.
Well, thank you very much, Tony.
Fun.
I do appreciate it. And Carl, if you've got any questions, let me know, and I can get any information from PhD Tony. And yeah, so thank you very much, guys. I'll speak to you both later.
All right.
Good night.
Bye.
Bye. All right, thank you for watching, everyone. That was a bit of a calm flat Earth debate, which is always a nice surprise. No one screaming at each other. Carl, just as nutty as normal, but actually pleasant to talk to, doesn't over talk. So there we go. Thank you very much. Now, just before we go, though, very important question for everybody. Can we pretend that airplanes in the night sky are like shooting stars?
Can we pretend that airplanes in the night sky are like shooting stars? Should be wishing for a brain right now, brain right now, brain right now.
Good morning. These words come with a storm warning. Better batten down the hatches, grab some matches and brace yourself for a long day of misery. YouTube has given me the power to reach up into the sky and show you all that we live on the ball. I bring you science that's comprehensible. Your view is indefensible. You're reprehensible.
Go on, Mr. Sensible.
When I was young, I never thought I would be here to see this. A pile of random nonsense dressed up as bull. Your ignorance will be the death of us all, like running head first, full speed into a wall. You could always read a book, buy a telescope, set it up and take a photo of the moon, or just be a buffoon. I send you in a balloon up to the stratosphere, page 3.
You're a few fries short of a happy meal. You're dumber than a box of hair. The wheel's spinning but the hamster's dead, and you're as smart as bait. You forgot to pay your brain bill. You're missing a few buttons on the remote control. 24 cents short of a quarter. You're surfing in Nebraska. You're as bright as Alaska in December, and you fell out of your family tree. You don't have all the cornflakes in one box. You got an IQ of 2 and it takes 3 to grunt. The elevator doesn't go all the way up, and there's a vacancy on the top floor. Your antenna doesn't pick up all the channels. You're several nuts short of a
Yo, Mr.
fruitcake.
Sensible, calm down, don't go too hard. You don't need the hard burying Flerfs in your backyard. You're a man of science, poise and grace. Mage 2 did everything to wipe the grins off the face. So Nathan, get away from those kids. The world is not flat and it doesn't have a lid. Recognize the differences between the textbook and the Bible and control yourself. Lay off your slander and your lies. You're a bunch of knobs poisoning the well of the youth. Spreading lies that you like to claim as knowledge and truth. Stop spreading fresh bullshit like the butter on your bread. Maybe your musical assault will knock some sense into your head. I hope one day you'll hear these lyrics and smile, and you realize you used to be a 40-year-old child. Now it's time to wake up, open your eyes and see, and acknowledge the existence of.
You're a few clowns short of a circus. Your phone is off the hook. Your sewing machine is out of thread. You're all foam and no beer. You don't have all your dogs on one leash. An intellect rivaled only by garden tools. There's no grain in your silo, and your skylight leaks a little. Your belt doesn't go through all the loops. You couldn't pour water out of a boot without instructions on the heel. Your slinky's kinked, and you're proof that evolution can work in reverse. A few feathers short of a whole duck, one fruit
Can we
loop short
pretend
of a
that
full bowl.
airplanes in the night sky are like shooting stars? Should be wishing for a brain right now, brain right now, brain right now. Can we pretend that airplanes in the night sky are like shooting stars? Should be wishing for a brain right now, brain right now, brain right now.
You thought it was over? Well, I'm still standing while you're swinging, flinging feces, talking shit just like the human centipede. You got the mind of a chimp, and I'm here to expedite your shore leave. Cause I'm a seaman, but not the kind I rit up from your mom's gums. I'm the kind that sailed submarines and fired guns. I could float a boat across the ocean with my eyes closed, circumnavigate the globe with a compass and a bag of sausage rolls. Well, all you can do is nibble on your toes. I'll smack you with the hose that you call a water level, sit and swivel. You nasal gazing muppet, you can stuff it harder than the wallet stuffed by Warren Buffett. And I don't care about your sauces unless you're serving them. And I don't care about your lines unless you're curving them. Now step away from me, you're sucking up my oxygen with the vacuum where your brain should be, you dumb fuck.
Thank you for watching, guys. Do appreciate it. And thank you to NA for Bacon, who says for $66.60, facts are facts. Green Lantern movie sucks because mostly he sucks as a DC hero. Bad. It's only second to Supergirl. Supergirl was the best Red Lantern ever. Marvel rules, they're alright. Even with Captain Marvel, can't wait for the next shit show DC. Star Wars sucked from 7, 8, 9. Fight me, but yeah, you're right about Star Wars. Thank you guys for watching. Remember, stupidity is not alright. Fight the flat earth.